yes, I'm a Twitch partner now. It's weird. And it's so good. I was like joking about it because this was the third time I applied for a Twitch partner. So I was just like, oh, it's not going to work. They're just going to reject it again. Especially this time, I was like, okay, I haven't been streaming that much. So I figured like, okay, it's just not going to work. But then I like jokingly wrote on Discord, I was like, third time's the charm, right? And turns out it was. So yeah, it's really weird. They do like take other things into account rather than just like your streaming numbers or whatever. And I did mention that I'd quit my job to like do streaming and content and stuff like that full time. So maybe that helped. That's what I imagine at least. But how do the assignments go with the grid stuff? It is kind of difficult to do some of these things when it comes to like, you know, where do you draw the grid is actually kind of complicated because, you know, you probably want it to be near the camera, but drawing it like infinitely everywhere is not a good idea either. Especially for something like the polar grid, which very much needs a center point, right? Yeah, if you wanted to do like a proper grid, you would probably do some sort of, you know, kind of like Unity's grid shader of like making it fade into the distance and all of that type of stuff. And that's kind of more involved, but it was mostly an exercise in expanding the editor scripts and also doing a little bit of math from, you know, the last math course. Before lunch, I was thinking I could walk through all of the assignments. Right, so let's see, what was the first assignment was that there should be some way to set the grid size or the grid granularity rather, where it's kind of the, either you can set it as, you know, grid units per meter, or if you invert that, that would be like meters per grid unit, so like the size of a single grid unit. It's kind of up to you how you want to set that up. It's sort of like a density function. So you could call it whatever you want, and it doesn't really matter which way you go. Yeah, so let's set up a value like that. So what do we call it? Do we want to do meters per grid unit or grid units per meter? I feel like the size of each grid cell is probably a little bit more intuitive for people. Because then if they want to snap every 5 meters or whatever, they type 5, and then that's kind of, that probably feels more intuitive. Let's call it grid size. Default to 1. Maybe a vector 3 floats to define the size of it. You could do that. I don't think I personally ever had a use for separating X, Y, and Z for that. But yeah, you could do that. I'm gonna go with a float in this case though. Makes things a little bit more clear, I think. All right, and then like last time, we need some way of displaying this value, right? We're gonna do the undoable version where you can like just use the property fields and then you can undo them, so we don't have to do the whole undo system manually. So in that case, we need to do the same thing we did before, where we get the serialized object, and then we get the serialized properties of all of those things. I don't think there's a serialized object field, is there? No. All right, so now we've gotten the serialized version of this object, and then we're getting the grid size property of this, right? And then we'll go to the UI. Let's see, I guess all the settings should be above the snap button. All right, so we're gonna do editor GUI layout dot property field, and then our property grid size. And don't forget to do the serialized object dot update before you do any of these controls, and then afterwards you need to save them. So apply modified properties. It's very easy to forget that, and then you're wondering why things like don't save, and yeah, it gets weird. All right, so if we now go back, recompile. All right, that looks visible. Neat. So now we have a grid size parameter. We can't really do a whole lot with this right now because it's just a number. It doesn't actually change the snapping of these objects, right? Just reorganizing because of the... What is Windows doing? You know what? That's fine, Windows. Okay, I'm gonna leave it there. All right, so we have the property field, but now we actually need to implement it, right? Because right now, if we snap something, it only snaps to the nearest meter, right? Okay, so what we could do is that we could change the round function to have some sort of parameter in it so that we can set, you know, what grid unit to snap to. Because right now it just snaps to integers. Also, this extension method should probably not go in this file. So I'm gonna add another script. Call extension methods, make it static. There we go. Okay, so this one only rounded to the nearest meter. And now we need to make, now we need to have some way of being able to snap to other units, right? So let's make another function. Public static vector 3 round, and this vector 3 v, and then another float for the size of each grid unit, right? Okay, so if you want to round to some other unit than 1, a very common way of doing that is that if you have some value x equals, or some parameter x, then one way of rounding it is to do math round, and you round x times size, actually divided by size, and then times size. So you're kind of rescaling it. So you put it in sort of a different space, and then you snap it in that space, and then you scale it up again. So that can sort of help you do all of that math sort of like very easily, and so you don't need to like manually find the nearest number or whatever. So it's kind of a neat little trick. So in this case, it's going to divide it by 2 in case size is 2, right? Which means that it's going to snap to further points than it did before, and then it's going to scale it back up again. So it's going to divide by 2, snap it, and then scale it by 2. So this means that it can't land on any like odd numbers, right? So in this case, we're going to do it with a vector though. So we want to return the rounded version of the vector v. Can you not divide? Hold on. Right, because we don't need math.round. So we take the vector and divide it by the size, and then we want to round it, right? And we can use this method to do that as well, right? So we can do v divided by size. So that takes the vector, that is the position of this object. We divide it by the grid size, and then we round that, right? And then we multiply it by the size again. So then we're scaling up the vector to its original position, right? Except this time it's going to be snapped. So this function is calling this function right here. If it's might look less confusing if we call a function directly. But I don't know. I like typing it like this. It looks neat. This is where we're actually snapping it in the snapper tool. But right now we just round it with the old function, but we want to use the one that has the grid size, right? So then we add the grid size. So then that's going to call this function instead, which takes the grid size and then rounds it within, it scales it down, snaps it, and then scales it up again, which does exactly what we want. Hopefully. We'll see, I guess. So what positions do these have? They have various positions. Neat. So let's say we have a grid size of 1. Actually, let's see if that's undoable. Yes. Okay, good. So grid size of 1, snap selection. And now these are all snapped to integers. So let's undo that. Set grid size to 2. And snap selection. And now they're all snapped to even numbers. There's not one odd number here. When we snapped a grid size of 1, we actually had a 3, but now we don't. So it looks like it works. Let's undo a little bit more. Let's try snapping at 0.25 increments. Snap selection. So that one is at negative 2.5 and negative 5.5, negative 2.25. So it looks like it's doing the correct thing. Neat. What did you set the prop grid size to? So prop grid size is the property that we want from the serialized object referring to the grid size field. So we use find property of the serialized object to find whatever property we want from it. So we're matching the name of that field here. Yeah, so that's what we're setting it to. And again, you don't have to use a serialized object and a serialized property. I think quite often it can feel kind of boilerplatey to like have to add all of these like extra functions, even though the value is right there, right? And you're like going through this weird, you know, diving into the serialized part and then getting the values there and then, you know, updating it and applying it. But again, the advantage of doing this is that it doesn't matter as much for editor windows, but it does matter in terms of the undo system, right? For other objects, it matters more because if it's an object in the scene, unlike editor window, then that scene needs to get marked as dirty. Or if it's an asset, then that asset also needs to get marked as dirty if you edit some property or whatever. So those things doesn't really matter in an editor window. And quite often I just don't do this in case it's like a very simple tool and we have a deadline and I just need to do it very quickly, right? Then in that case, I'm not going to care, you know, too much about making it undoable or whatever. But it's not like that much extra work. So I think it's very worth it in many cases, especially if it's a tool you're going to use a lot. The next part of the assignment was to draw the grid, right? So drawing the grid in this case would be something we do in during scene GUI, because we did add this one line that we're drawing. That's just this little white newt sticking up here. So we want to do that, but for the entire grid. And that grid should then also respond to the changes you make in grid size, right? So there are a lot of like, there are a lot of decisions you can make here in terms of design. Like, where do we draw the grid? I think for now we can just draw it, you know, near the world position as kind of a first step. But otherwise, if you want to make a proper grid, you'd probably want it to be infinite, but also not, it also has to be performant, right? So you can't just, I don't know, you can't just draw an infinite number of lines, right? So that gets more complicated, but for this exercise, we're just going to simplify it a little bit and only draw it, you know, with a limited range. There are like other things you could do as well. You could, I was thinking about this earlier, like what would be a good way of doing this? One thing you could do is draw the grid in the bounding box of your selection. So if you select it, then you draw the grid around the objects you have plus some like margin around them. I think that might be neat. But anyway, let's just stick for the world space coordinates now. So we draw them around the origin with some limit, right? So let's see, we need some like value or some constant for how big we want the grid to be. So I guess we can set some hard-coded value for that. Let's say, how far should it extend from the center? 32. I know, let's say 16 meters, that's probably great. I don't know what to call it. Extent, I think is the correct word. Because it's not the, like, edge-to-edge size. It's center-to-edge. Actually, grid, draw, extent. There we go. Okay, so now we need to draw a bunch of lines, right? The, let's open Photoshop. It feels really weird to have DPI scaling, I must say. All right, so we have the world origin now, right? And in the world origin, we have some x-axis. And if we want to draw it top down, we would have x and z, right? If you look at the top right, that would be x and z. That's on the plane we're going to draw this grid, right? So we would have these axes. And then we had the value that is grid draw extent. And grid draw extent is essentially going to be the distance at which from the center we want to draw the grid, right? So this is going to be the extent. And then we're going to draw the grid from that extent all the way through the center and then to the other side. And then we have the same extent in this direction, so we're going to draw lines like this, right? So we need to do some sort of for loop to iterate through all of these lines, right? So we would need to figure out how many lines do we want to draw and from where do we start, right? So I would probably set up some way where we can say, this is some starting point, and then we have a number of lines we want to draw. And then we do a for loop that would then, add every step along the way for the lines. So let's calculate that. So we have a world space extent of this, but the number we have is the, what do we call it? We call it grid size, right? The grid size is meters per grid unit, right? So what we can do is that we want the number of grid units for this. We would have the extents. The smaller the meters per grid unit is, the larger we want the number of lines to be, right? So we would need to divide it in that case. So then we can do int grid lines or line count equals grid draw extent and then times 2 because we want it to be across the whole thing. So it would be this distance right here rather than half of it. And then we divide that by the grid size. Oh, actually, I realized that this might not actually work. No, this plan won't work. If we have, I made a mistake. Jeez, it's over. Rip. If we have a grid unit that doesn't fall on this edge of the extents, it's not going to work. So rip that. Let's see, new plan. Right, so we wouldn't actually find we wouldn't find the point of this one because the line could fall here. That's like inside of the extents. But what we would do is that we would use the grid size to figure out what is the bounds that is closest to the extents, right? And that's fine. We just have to change the math a little. So instead of finding this point and then adding to it, we would rather use the origin and the number of these as our guide for how we should draw the lines. Right, and this is probably sad because we need to round this. And then we need to make some sort of for loop. It might actually be more useful to have line count on one side now that I think about it. So now I basically want an index for each of these lines, right? So if we consider the vertical lines in this case, I would want an index like 0 in the center, and then -1, -2, and then 1, 2, 3, and 4, and so forth. So basically we need to be able to convert from, iterating through all of these just straight up, where it's, 0, 1, 2, 3. We need to convert that to these numbers. So then basically it would be the integer offset from center rather than, going from one edge. So in order to do that, we would need to divide it by half of line count, right? Or not divide, sorry, subtract. Or this is kind of the integer offset in grid space. So that would be half line count and that's an integer. So these are our integer offsets. So then all we need to do to get these coordinates is that we have these basis vectors, right? So we can actually just shove those coordinates into the basis vectors and then scale it by the size of each grid unit, right? Because if we multiply 1 by the size of a grid unit, that would become this distance, right? So this would be our x coordinate, right? So that would be integer offset times the grid size, right? So now we basically have the world space coordinates of, or the x coordinate of all of these, right? But we don't have the y coordinate, so we need that. So the y coordinate would be, we take the other axis and then we use the full half count of that, right? So then we can do y coordinates. So that would be half line count times grid size. But we have two y coordinates, right? Now we need these y coordinates, right? Because for every line we draw, it's the same x coordinate, but we have two y coordinates. We have this one and we have this one, right? So then half line count would be going from the center all the way up there, and then we scale it by the grid size, right? So we have y coord 1 and y coord 0. So the only difference is that we would negate one of these, right? Right, and then we draw a line. Let's set up the points. Right, it's a vector 3, sorry, because we need to make sure that we get the axes correct, right? It's not on the xy plane, it's on the xz plane. So technically, I guess both of these would be z coordinates, right? This code got messier than I thought. That doesn't seem to do anything. Question is why? Oh, vector 3. That's better. Also looks wrong. Right, because we're not using I. We're not actually using the we're not using the actual integer. So we wanted to use these and then subtract, right, subtract half line count from it, right? So we would do I minus half line count. So this would give us the integer offset. I'm sorry, I missed that. And there we go. Now we have some sort of grid on one axis, but not the other one. So now I just want to make sure that this is actually valid. Thanks, GeForce Ready driver. So that does seem to scale. That's good. Let's add a cube. I usually use Unity cubes to double check my sizing. They're pretty useful. So in this case, it looks like grid size 1. That looks like 1 meter. Let's see if we snap this. That looks good. Yeah. Cool. We got some off by 1 issues. Classic. Okay, so I guess, let's see. Where would we do that? I feel like line count has to be odd. If line count is even, do we add 1? Is that what we do? Looks like it. Okay. Because we have the line in the center, right? So whatever grid division we have, it would be center plus an even number of things on the side. So that's why if we make sure it's always odd, we have a center line and then symmetry on both sides, right? Yeah. Cool. So now we got parts of the grid, right? But then we need the other part of this grid. Now we just have a single one. So the other axis would be the lines going along the x-axis. So these are just the ones going along the z-axis. So I think we can... What in the world happened? So I think we can do this, where all we need to do is we swap these two coordinates. I'm pretty sure we can do that. I don't think we need to calculate all of this again. And there we go. And now we can set the grid size. This is a lot of grid. I'm surprised it actually doesn't lag. Neat. Might not be good to do that now, but I was just going to say that I probably wouldn't want to have this be fully visible. It's probably good if it's like a little bit transparent. I guess if we want, we could set the color. We could set the color based on how far away it is from the center, but that's a little bit not what we're supposed to do, I guess. Actually, we should probably make sure this works before we move on. Also, I'm now seeing that this is drawing on top of all the things, right? Excuse me. So let's set the Z test of the handles. It's a bit of an esoteric term. If you're familiar with shaders, this is a term that's used for determining when to draw a certain pixel, given if it's behind or in front of the depth buffer of like everything being drawn in the scene. So we're going to change that to less equal, because it was set to always before, which means that it always draws, but we wanted to only draw if it's less than, as in closer to the camera than the current background, or equal. So that's why it's called less equal. So now it's actually under these objects, so that's good. All right, so let's see if they actually snap to the increments that we tell them to snap to. So we set them to 4. Blinked, what did you do? Oh, I set the handles.z test to compare function.less equal. This means that the grid is going to do depth testing and read from the depth buffer and only draw if it's in front of other things, but not if it's behind. Yeah. You can also do greater equal if you want to make things like, it's really weird. Now it only draws if it's inside of stuff. So now we have a grid that's like only visible if it's behind objects. But that's not a very useful grid, so let's not do that. All right, let's set grid size something reasonable to 2. And then let's try snapping all of these objects. Go away, sunlight. Select all of those and snap selection. Now everything is snapped. I can undo that, change grid size to some weird, there we go, some weird floating point number. And they still seem to snap reasonably. Okay. Neat. When we do barrel explosion, we're not going to do a barrel explosion. We don't deal with art when we're in coding class. Jeez. I really want to do an explosion VFX stream for Flowstorm, because I really want to, like, a lot of the VFX is like missing there. I'm doing our waypoint assignment and I made a handle stop position handle. Is there a way to make that into an object which is selectable? Wait, is it not selectable? I thought it was selectable. Oh, wait, as in you can like click an object and then it's added to your selection, or? Right, you can move it around, but you cannot like select multiple. That is surprisingly convoluted, and I have only done that like twice because there's so much boilerplate in doing that. I can probably show you. Hold on. Okay, I've done it before, so I'm just gonna show you that code instead of like pretending to remember. The thing is that like it's quite often so much boilerplate that I just never do it whenever I write like. Fine if I'm writing like a proper plugin, but if I'm just in a project and again with deadlines and everything, I'm not going to care about, you know, doing the most intuitive tool. Because unfortunately, when you're in a production, like a lot of the tools you're making are just incredibly not perfect. I just wanted to register so I can undo redo and I move that vector 3, which is in a list. Oh, if you just wanted for undo redo, in that case you could, then you would do the quote unquote bad way that I showed you before, where you do undo record object on the object holding that vector 3 list, right? And you need to record it before you change that variable. So you would do something like, you have your position handle. If you move it, if the value has changed, record the object holding the vector 3 data, and then change the data, right? That would be the way to do it without the property fields. Okay, sorry, I'm just opening a project now where I have handles. I can show you how to do it if you want to, if you want me to clarify or whatever. But then I'm solving your assignments for you. Is that really what I should do? That seems dangerous. So here's a project that I worked on a while back. So this is basically I did a stream on how to do procedural mesh generation in Unity. So basically generating these meshes. So that you have like these Bezier curves, and then you can like rotate and you set up these little roads. So I have these handles that are draggable, and these are using the Unity's like handle system. I'm not actually dealing with selection, I'm just noticing. So I don't have like, I'm not caching selection on those objects. But yeah, so these are basically using Unity's handle system. And it's kind of like, it seems like one of those things that should be relatively easy to do. But it's actually surprisingly convoluted because of how Unity's UI system works and there's like immediate mode selection shenanigans. So let's see if I can find... probably this one. It's a cancel. Okay, so it gets very messy because there's like, oh, I don't know where to begin on this because there's so much like boilerplate. So basically there's the draw tangent handle, and that would be both of these two handles. So there's one function to draw either of these two. And then there's a bunch of stuff for like getting the handle size. This is a pretty useful function, handle utility.get handle size. That one is sort of like, it gives you a screen relative size so that if you move the camera further away, it will scale up, and if you go really close, it'll scale down. So you sort of have a like screen space size of the thing, right? Which is pretty useful. Yeah. So, okay, and then there's a bunch of shenanigans you need to do of like, you know, are you dragging this object? Are you hovering this object with your cursor? And you do all of this with like reading the control of the UI utility and the handle utility. And this is something I do very rarely because it's a bit of a mess. We're also soon going to talk about how the immediate mode UI branches, where you have the concept of a UI event, and depending on that event, you can do different things. Right now, we've just called, right now we've sort of just had this UI function, but we're not branching anywhere. We're just doing the same code regardless of what we're doing, right? Technically, that's bad. We shouldn't do it that way. So yeah, the reason this is bad is because during scene GUI, it's going to be called multiple times, even during a single quote unquote frame in the editor, right? So what we want to do is that we only want to do all of this code during a specific UI event, which we can check if event.current dot type equals event type. Why does writer suggest the like deprecated versions before the non-deprecated? Anyway, event type dot repaint. So that means that this is the UI loop that is drawing to the scene, right? That's when we want to do all of these things. Otherwise, we don't want to run this code because this event is going to get called every time you click, every time you scroll the mouse wheel, every time you move the cursor even. So that's something you need to keep in mind whenever you do UI, that if you want to do more advanced stuff, then branching based on the event type is going to be important. Yeah. And that's a whole category of things that I don't know how much we're going to get into that. We're going to get into it partially for the next thing we're going to do, but yeah. Sorry if that was like a lengthy explanation of that. So that's what you're seeing here. There's a switch, and then depending on all the different event types, we're going to do different things, right? So yeah, so you can see that there's an event for layout, there's an event for mouse down, there's an event for mouse drag. So that's when I set the states of various stuff. That's when I set, whether a control is selected or not, and so forth. So whenever you do this type of stuff, this is a general tip. Whenever you do editor scripting in Unity, there are so many things that are completely undocumented, and it's very hard to find resources of this online. So I did this especially during the ShaderForge days, because there was like nobody did editor scripting. Generally people just never made tutorials about that either. So what you can do is you can decompile Unity's editor. And it's there are various decompiling tools, like ILSpy I think is one of them. Some IDEs have really good decompilers. So a general tip is if you don't know how to set up a specific thing, I don't know, if you do, good example is probably light probes, right? So this is a very bright background. So if you look at the light probes, then light probes have these you can select these individual things, you can move them around, you can select multiple of them if you hold shift. So this is a whole selection system within an editor for probes, right? So if you want to learn how to do that, as in have individual selectable things, then looking into the decompiled version of Unity, and looking at, how does the selection of light probes work? I think that would be where I would go in case I want to see how to do that. Unity does have, on GitHub, they have the C# source of the editor, but it doesn't include everything. So it kind of depends on where you, what thing you need. Sometimes it's available there. So I can show you Spotify. Unity CS reference. So on GitHub, you have Unity's C# reference. And here there's a bunch of things if you want to look it up. So if you search for the math class, well, you can hopefully find that. But now I'm not finding it. Excuse me? Is it because it's searching for... How is this the best match? Is it called math.cs? Okay, why does this not go to the math class? Anyway, but you can go to like various source code in Unity if you want to look at, you know, say this one, color utility. How did it not find math? Okay, here's the math file. So if you're curious about like how some math function works in Unity, well, you can, here you go. You can like look in the source file of this and be like, okay, so this is how the max function works. This is how the pow function works, and so forth, right? And you can be like terrified at how Unity is like calling the like double versions of the library and then converting everything to float, because this is the built-in C# math class, and then you have the Unity's version. That's kind of weird. Isn't that strange? Anyway, yeah, so generally, if you want to do like more advanced editor stuff, decompiling is super useful. Like I did that when I was like, okay, how let's see, let's open, let's say I select a mesh like this. So a mesh like this, you can like click and drag this thing, right? And it's showing a mesh in like editor UI. That's all something you can do as well. But for me, when I started doing stuff like ShaderForge, then I was just like, how the heck do you even begin to do this, right? And that's where like decompiling stuff became very useful. Anyway, sorry for a long random rant when we were supposed to go for break. I'll have to watch a replay because I'm completely lost with serialized property being null. If serialized property is null, then that's probably because the field name doesn't match the doesn't match, right? Yeah, the grid size, these two have to match exactly, right? And also make sure the serialized object is of the right object. Like make sure the object you pass into this one is the correct one. If this would be like a custom editor rather than like a custom inspector, in that case you don't want this, in that case you want target. And then this would be in the object you're inspecting, right? Although actually you would use the serialized object field in the inspector, not do new serialized objects. Does that have to be public? It has to be serialized. So if it's not public and you haven't marked it as serializable or serialized, then it's not going to work. So yes, that was probably it. If it's just private, it's not going to work. Right. So someone asked about the position handle, right? Oh yeah. By the way, if you want to learn how to like do all of this stuff, there's I have a tutorial on my YouTube on how to do procedural geometry in Unity. So feel free to go there if you want to learn about how to do procedural meshes, because these are all 3D meshes. You had a bunch of points, right? And then you wanted to be able to move them using the position handle, right? So let's set up a single point just for simplicity. Right, and then my point equals handles dot position handle. All right, so this is kind of the basic setup. I believe this should work. Yeah, because now we don't have anything selected, but there is a position handle here now, right? Okay, so you wanted to be able to undo that. So there are different ways of doing this. So either, which is probably what I would recommend, is that you do the serialized property version of this, where you make sure your point is serialized, or your point array is serialized. And then you do the same thing we did before of like finding the property, all of that stuff. And then you modify it within the like you do so.update and then so.apply modified properties, right? Like you would do this, but with your array of points, right? Does that make sense? So then basically you would have a serialized property of your prop point. And then point is currently not serialized. We would have to make that public. And then we do point, prop point. And then instead of just writing point, we would do prop point and then dot the type of value we want from the serialized object, right? Or the serialized property. In this case, it's a vector3 value, right? So I want to assign to the vector3 value as well as read from it here. So this is kind of how you would read and write to properties manually. And then don't forget that you have to do that within an update and an apply modified properties, otherwise it's not going to save. So I believe this should work. Could be wrong. So if we move this, move, 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 undo, undo, undo. Yeah. Find it harder to figure out while the point is in a list. Yes, that gets a little bit more complicated because then your serialized property is an array, right? So you would need to iterate through those. I don't remember exactly how you do it, but I believe there's an array size. So you could do a for loop of array size, and then there's a prop point dot get. I think there was a child or array. Get array element at index. There we go. So then instead you would do something like this. So then you get the serialized property of the array, right? Or the element in the array. And then you would do, then you would use that property instead. Like so. So then we make this into an array. Rename it to points. I'm actually not sure if this works, but I feel like it should work. There we go. We got 4 points. So we update, draw all the handles for the points. This one needs to update as well. Should call this prop points. Let's see if that works. That does seem to work, yeah. And undo works fine, redo works fine. Yeah, so then this is how you would do it. So anytime you have like an array of, or even if you have an array of a type that has lists in them, then you would kind of go deeper and deeper into all of your serialized properties. So serialized properties can refer to, children that are also serialized properties, right? If you have a more complicated data structure, like, how we did find a property in serialized object? If your property is like some class that has a bunch of different properties in it, then you can even do prop dot find property relative, and then you would basically find that property dot point or dot rotation or whatever you would want, right? So then you would find the child properties of that property. So if you have nested stuff, then you would use find property relative. But specifically for arrays, you would use the get array element. Yeah. Really helpful. I would hope so. That's why I'm here, to be really helpful. Great. I figured maybe it's good to keep this in the file in case you want it. In case you want to copy paste it for your assignment and not learn anything. Yeah? Is that what you want to do? Jeez. Wow. Students today. So we were talking about doing a polar grid, right? It is a very specialized thing, but we did have a use for that when we were working on budget cuts. So we set up a lot of grid systems like that. There are also some design questions, like how do we switch between these two grids? So I would say Maybe we can have an enum or something where you can switch the enum either to Cartesian or polar, right? So let's set up an enum type. All right, and then set up a property for grid type. Should we use grid size for, yes. Okay, we can use grid size for the polar one as well. So grid size would be the radial grid size when we do polar coordinates, right? So previously we had this Cartesian grid, right? But now we're gonna have a polar grid, which means that instead of having, you know, lines just aligned with the world axes, it's now gonna be a radial grid where we have distance grid like this, right? It's gonna be distance from center. And I'm thinking we can use the same grid size value for, you know, the distance between each grid line in the polar grid as well, right? So we can use that same value, but we need a second value for the polar grid, right? For, you know, what are the angular increments we should snap to? Because there are many of those. And you might want to choose that separately. So maybe you can specify the number of angular divisions. So in this case, it would be 8 of them, right? Yeah. So we would need a second property for that, for setting up the number of angular divisions. There we go. I can draw straight lines, I promise. This looks a bit wonky, but you get the idea, right? All right, so our grid type, we should probably default to grid type.cartesian. Then we need a property for the grid type. What else? Right, we need the grid, like angular division, right? So that would be an integer. Can start at 8, I suppose. Actually, let's do 12. That's gonna look cool. Isn't that Unity's default rotation snapping? Oh, it's even more than that. 1, 2, 3, 4, 5, 6. So it's 24. Let's default to that then. All right. And then all the boilerplate for this. Cool. I think we got everything now. We have the grid type and angular divisions, and that's all we need. Now we just need to set it up in the UI, right? And we don't want that in the scene view, or I guess we could actually draw it in the scene view if we want to. But in this case, we've got it in the editor window. So it's down here. So we have the grid size and then snap selection. So we would probably want editor GUI layout dot property field, and then the grid type should probably be one of the first ones. Oh, prop grid type. And then if it's a polar grid, then we also want to be able to set the angular divisions, right? So we could check the type here. Actually, we could go directly to the grid type. So if it's polar, then we want to draw another property So that's going to be the property of angular divisions, right? And then let's see what this looks like. All right, so now we have grid type Cartesian, and then we have grid size, and that's still working. And if we switch to polar, we now have angular divisions as well. Neat. We can set angular divisions to negative values though. That doesn't feel super great. So maybe we should add some prevention to keep that from happening. So let's set its int value to math, the maximum value between, we can set a minimum of 4, right? So set it to the biggest of 4 and the current angular divisions. This is a very like shader coder way of doing this, I guess. The more regular way of doing this would be if the int value is less than 4, then we set it to 4, right? Yeah, you can do it whichever way you want. I'm just very used to writing shaders at this point, so I probably do things in a very strange way. But it's good to learn. It's useful. It's very fast, so. All right. And now it stops at 4. Good. So basically the property field here is going to set the angular divisions to whatever we set it to. And then if it's set to some negative value or a value under 4, it's then going to get clamped to always be at least 4, right? All right, so now we also want to branch the way that it's drawn and the way that we're snapping stuff, right? Because now both the snapping and the drawing is wrong as soon as you set this to polar, right? Okay, so let's see. Let's do the drawing first, because it's really difficult to see whether or not the snapping is working in a polar grid, because we can't just read the values off of the transform to see if it works, right? Yeah. So let's draw it. Where do we do drawing? That would be during scene GUI. And this is a whole thing. Trying to figure out what we want to keep from this. Doesn't really matter. Let's move this into a separate function at the very least. That's a Cartesian grid. And I believe I can just slap all of that in there. I should probably learn how the extract function macros in Writer. Sorry, extract method if you want to be super picky. All right, so now we just separated this out into a function, which means that it's a little bit cleaner if you want to branch this based on, you know, what grid type you're using. So in this case, we want to do if grid type equals Cartesian, then we draw the Cartesian grid, else we make another function for draw grid polar. Okay. So now we need to make similar things as we did before. So we have the grid draw extent, and then we also have the grid size. I feel like we should probably put this in separate classes. It's kind of weird to have it in here, but let's have them in here for now. So draw grid polar. We're going to need to do something similar to line count, but something the line count did was that one started at, we kind of included every single line on both sides of this, right? So line count contains the number of lines across the whole thing. But in this case, we want to draw radial segments, right? That's or rings around the center. And then we only need this on one side because they wrap around to the other side. So we need half of that number, right? So line count for the polar grid, we don't multiply by 2 here. So this would now instead be ring count. Oh. In this case, we don't need to make sure that it's even or odd. It doesn't matter in this case. Okay. Right. And then I think we can just start making a for loop. So we do ring count. And we skip the first one because the first one is just gonna have 0 radius. So we might as well just skip that one. So let's just set I to 1. Now we're going to draw some rings. So we want to do a wire disc. Let's see, do our rotations or normals? Center, normal, radius. Perfect. So center would be just vector3.0, or sometimes you can type default if you want. So default is going to be the same thing as vector3.0. But in this case, it might be good to type vector3.0 because we want to specify that it's the world 0 coordinates, right? And the normal, so the normal would be the up vector in the world, right? That's the normal of the disk. So the normal is pointing up from that disk, right? So that's going to be vector 3 dot up. And then finally the radius. So the radius, we want to change that per iteration, right? The first one should be grid size in radius. The next one should be grid size times 2 in radius, right? So it's I times grid size. Excuse me. All right, so now we have a bunch of rings. It looks like it works. Let's see if we can change grid size. And it's making a bunch of rings. And we got some really nice wire patterns. I love this. Neat. Was that clear so far? Any questions about the rings? Probably not. This is like easier than the Cartesian grid, I feel like. Because it doesn't have the weird separation between X and Y. Right, but then we need the angular lines as well, right? Because now we just have the radial grid, but not the angular grid. So let's do that as well. Okay, so basically what we need to do now is that we need to so now we need to draw these lines right here, which means that depending on the number of divisions you have, this angle is going to be different, right, between each segment. So we need to find some way to go from an angle to a position, right? Because we don't really need the angle. We need this position right here, right? And then for the next line, we need the next position and so forth. And if you remember trigonometry, then this is where we can use trigonometry. I noticed that handles.draws normal is vector3.up in both cases. You've used them. Is there a case where it's not? So this depends on the orientation of the disk that you want to have, right? So if you want this to be on the XY plane, then you would set this to forward instead. So now if we recompile, it's now going to align with XY, right? So it's just the way you set the orientation of the circles, right? And yeah, so that's how we specify the normal. So one use case would be like, if you want this to be relative to an object, where if you have the grid circles here, and then you rotate this object, then you want the circles to follow along, right? So then you would set the normal of the circles to be the normal or the up vector of this object, right? But in this case, we're kind of like just axiomatically decided that it's going to be on the XZ plane, right? So that's why it's vector3.up in this case. All right, let's make another for loop. So in this case, we're going to go for the angular divisions, right? So we have the angular divisions here. And then we need the vector going from the center out to this point right there, right? So the way to do that is that we first need this angle, and then if you remember from trig, we can get the x coordinates of this, as in, that kind of looks like a y coordinate. It depends on how you interpret this, I guess. We can get the x coordinate of this one using cosine of the angle, right? And then we can get the y coordinate of this one. Oh geez, not a lot of space. Using the sine function. So then we're going to get the normalized vector, as in a vector with a length of 1 pointing in the correct direction, given that angle, right? But we then also need to scale it, because we want to get the point at the very edge and not the one that's 1 meter from the center, right? So we then also need to scale it by the maximum distance that we want this vector to go to, right? So first off, let's calculate the angle, because we need that for the trig functions. So the way that I like to do this is that I like to think in terms of turns, which is sort of like a percentage for how far you are around a circle, right? So we could do, if you want this in turns, or rather percentage around all the angular values, then usually I call any type of percentage or interpolant, I call t. So in this case, we want I divided by the number of angular divisions. And we need to make sure that this is a float in this case. So what this is going to do is that this is going to be a value that goes from 0 and then goes all the way around, and then it's going to go from 0 almost up to 1. It's not going to hit 1, because in this case, we don't want to draw 2 lines at 0 and 1, right? So it's going to be 0 at this point. It's going to be 0.5 over here, and it's going to be 0.75 here, right? So we want to we start with this line, and then we go all the way around, and then we draw this line, but we don't want to draw this line again. So that's why we're not like going all the way to, that's why we're not doing angular divisions -1. So anytime we do something that's like, that loops something that is like circular, you tend to not do -1. But if you want to get like, say if you have, I need a bigger brush. Say if you have a starting point and an end point, and then you want to like get points along these, right? Then in that case, you probably want 0 at the first one and 1 at the last one, right? And then all the values in between. So like depending on how you set up the loops, the t value can go either from, 0 to 1, or it goes from 0 to almost 1, just like one step off, right? It's good to keep in mind. All right. I lost track of what I was talking about. Right, so we need to get the points of this one. And in order to do that, we need to get the angle. So how do we go from T to an angle? So in this case, we want the angle in radians, right? Which we talked a little bit about before, where yeah, it's just a type of angular unit where instead of going from 0 to 1, or instead of going from 0 to 360, it goes from 0 to 6 point yada yada, because it's a lot of decimals. And that value, 6 point something something, is sometimes called 2 pi, unfortunately, but I usually use the tau constant, which is equal to 2 pi. So all we need to do to convert this to an angle in radians, let's call it angrad, is to take the percentage, or the angle in turns, and then multiply it by tau, right? And I don't think I have a tau constant in this project, so let's grab that. Tau times 1. There we go. So now we converted this from a percentage, or turns, to radians, right? Or turns, rather. Because that's what the trigonometric functions are going to want, right? And then we can use the trig functions to get that normalized vector, right? So we can do... yeah, let's do vector 2 immediately. So this is going to be our direction, and that's going to be a new vector 2. So the x-coordinate of this one is going to be the cosine. So cosine of the angle. It looks a bit messy, actually. And then the y-coordinate is going to be the sine of that angle. So now we can make a direction out of this, right? So x and y. And now we have the normalized vector going from the center, pointing in that direction, right? So we're not quite done yet. I just want to show you what it looks like in case we don't add the radius. So then in order to draw this line, we would use the same functions as for the other one, where we do handles dot draw AE polyline, because we gotta get that anti-aliasing. It's important. We're going to draw it from 0 in the world, because that's our origin of this grid. So that's vector 3 dot 0 and the direction, right? Okay, so there are a few things that we have a few problems right now, right? We have some angular divisions here, but it's not drawing on the correct plane, and it doesn't actually draw all the way out to the edge, right? So let's fix the plane first. So one problem is that this is a vector 2, right? And since we want this on the xz plane, we actually need this as a vector 3, and then set y to 0, and set the quote-unquote y-coordinate of the 2D vector from the sine and the cosine values. We set that to the z component of the direction. So now it should flatten to the correct orientation. And then we can scale this one up to reach the edges of this one. So in order to do that, since it's a normalized vector, multiplying it by some scale is going to make it have the length you multiply by, right? So all we need to do is multiply it by, I believe, the ring count times the grid size. Let's save that as a maximum radius. Radius outer. So then we multiply that here. And then this is no longer a direction. This is a 2D one. We could also do that here. Right. So if we go back, recompile, and there we go. Now we have a polar grid. Although it bothers me that it goes one extra step So I'm gonna do ring count -1. Dude. Alright, so now we have a polar grid. So we can now switch from Cartesian to polar. So we're not fully done yet. So we don't actually have the snapping itself. Right now there's only drawing it, but it doesn't actually do anything. So that's the last thing we're gonna do, and then we're gonna go for lunch break at 12. Are you all okay continuing? I'm guessing we should just continue until lunch. There's probably not a big point in having a break. Yes, okay. Any questions about this, by the way? Because this is kind of recapping a lot of the like math stuff we did during the math course. But I'm guessing you're good. If not, feel free to ask questions at any time. Okay, so now we need to actually do the snapping of this one. So let's see. Let's collapse those. Snap selection. Okay, so now it's probably good to have like a separate function for snapping, because now we have this like snap selection, and then probably looks kind of ugly to have that code in here. So let's have a vector3 and then get snapped position, and then in there we can branch, you know, based off of which type you have. So vector3 original position, or pause original. So now we want to set that one to get snap position of its own value. All right, and then we branch based off a grid type. So if grid type equals Cartesian, then we basically return the original position and then rounded based off of the grid size, right? And then we're done with that one. So then let's move on to the polar one. All right, so let's think about this. Let's also undo a few things because I just cluttered this whole document. Actually, maybe this is useful. So I'm gonna send this to you and to you students in case you want it. You know what, Photoshop? You are terrible at copying right now for some reason. There we go. Let's send the other one too. Well, it's a little bit cluttered. I hope that's okay. Layers. What a concept. All right, so snapping in this case works a little bit differently than it does in the case of the Cartesian coordinate system, right? In the Cartesian coordinate system, we have two values that we snap, right? we have an X component and we have a Y component. Or we could call it Z in this case because it's in the Z plane, but if you imagine a 2D vector, we would call it X and Y, right? So we have these two coordinates that we're snapping. In polar coordinates, it actually doesn't really, you don't really have these coordinates in terms of the world space axes, right? In polar coordinates, you would have a distance from the center, which I'm going to call R because I don't remember what the official nomenclature for that is. So it's sort of like a radius, right? And then the second value is going to be the angle from the center, which is usually denoted theta. But I like using alpha because I think it looks more neat. So basically, instead of an X position and a Y position, you now have sort of like a radius or distance rather. Distance and an angle, right? So if we talk about snapping a polar coordinates, we're not snapping the X and Y coordinates of this type of coordinate system. We're snapping the distance and we're snapping the angle. So those are the two things we need to look into in order to do a proper polar coordinate snapping, right? So the distance snapping is very straightforward because if you think about it, these are sort of already distance snapping, right? It's distance along a certain axis that we're then snapping, and then distance along this axis that we're snapping, right? So the distance snapping is going to be very straightforward. That's going to work pretty much the same as before. The angular snapping, on the other hand, is going to be a bit more work, but let's start with the distance snapping. So what we need is the current distance, right? Basically, we need to convert the current position into a polar coordinate, right? So let's do that. So first we need the distance. So that would be vector. Let's see if it's a 2D plane. We can work in 2D coordinates for that, I suppose. Yeah, it's a bit of a weird way of doing it, but that's fine. Let's make a new vector 2 where we do the original position dot x, and then original position dot z because it's on the xz plane, right? Because we need to make sure that we need to ignore the height of the object, right? Because we want this grid to be just, it doesn't matter what height you're at, right? We're only snapping the other values, right? So, and then we need the magnitude of this one, which is how far away we are from center on that y plane, right? The xz plane or y plane, you can sort of call it different things depending on like what terminology you want to use. It doesn't really matter which. And then we get the magnitude of this one, right? So this is going to be the distance from center currently for this object, right? So now we have one component of the polar coordinates for this object, right? Actually, let's see the vector for this one separately because we're going to need that. Okay, so now as soon as we now switch to vector 2s, again, you need to, like we talked a lot about this during the math class, but keeping in mind what space you're working in is really important because it's almost always implied and it's always implicit in, what is a local position, what is a world space position. That's not inherent to vectors. That's something that you need to remember, right? So this vector 2 is using the x and the z position of the object. So this is sort of in the xz space, or yeah, xz space of this. So it's going to be sort of like a 2D coordinate where we have x here and y here, right? So it's important to keep in mind like what you're working with in terms of coordinates. So now we're sort of matching this type of coordinate system. As soon as we've like Sometimes it's called swizzling, if you take like a z component and put it in the y component of something. So technically, we've swizzled the original position into a vector 2, and we've also ignored the y position of the original one, which means that the function is going to do the same regardless of y position. So technically, this grid is sort of like a cylinder extending infinitely upwards, right? Okay. Cool. So now we're in the 2D space of this whole thing. Cool. So now we have the magnitude. So this would be the magnitude from the center in that 2D space. So again, if the magnitude of these two objects is going to be the same. So it's not the distance to the center of the world where you would have this distance and this distance, but it's rather we have this distance and then this distance to the line extending infinitely, right? Because we're basically doing the math right now in this type of coordinate system where everything is just flattened, right? I hope that made sense. All right, so we now have the distance, and then we can snap this distance, right? And snapping the distance, like I mentioned before, that's exactly the same thing we did for the Cartesian coordinate system, right? Because that's a linear snapping. So let's do that. So then we would do distance dot round grid size, and then that would be the snapped distance. We also don't have this function, so let's make that function. I absolutely love making extension methods for built-in types. It's one of my favorite things to do because it looks so wonky sometimes. So in this case, we would need to use math.round. Okay, so now we have an extension method for floats. So we can go back. And now we can do distance.round. So now we got the snap distance. Cool, now we have one part of this, but not the other one. So now we need to do the same thing for the angle. So we got the distance snapping done, but the angle, we don't have a way of snapping this one. So how do we do that? Well, first we need the current angle. We got the current distance here, but not the current angle. So in order to do that, there's a very useful function called math.atan2, which is sort of like a reverse of, doing a cosine and sine to get a direction. Atan2 takes a direction and gives you an angle. So it's sort of the opposite of those two. And for some dumb reason, you need to specify the arguments in y and x rather than x and y, because it's just what it do, I suppose. Okay, so we need to do atan2 of the vector dot y and then the vector dot x. And I believe this one returns radians. Yes, okay. All right. So now we have the angle in radians of the current position of this object, but then we need to snap this angle, right? So there are probably good shorthands you can do for snapping, but I like just like doing things step by step. So I'm gonna first convert this from radians to turns, which means that a full turn is gonna be 0 to 1, right? So then we take the radians and then we divide it by tau, which it's disappeared. Where's my tau? Oh, I probably put it inside of the, yep, nope. Don't have a math class in this project. Right, so now we have the angle in turns. So this is a value from 0 to 1. And this is a value from 0 to tau, right? And then we need to snap this. Then all we need to do is to multiply this by the angular divisions and then round that, I believe. Snapped, and then we do and turns multiplied by the angular divisions, and then we round that value. And then we divide by the angular divisions. I believe. Yeah, so we can probably use one of the other round functions that we made. I think the operators are different because these are specified in size rather than divisions. So it's kind of like one divided by the other, right? So we could use the other round function if we want. So then it would be angturns.round. But instead of specifying the size, we need to do the inverse of the size, right? So instead of we need to convert from divisions from a full turn to the size of a single division angularly, right? So that will be 1 divided by angular divisions. Because if you do 1 divided by, then you're kind of converting this to a divide, you're converting this to a multiply and this to a divide, which is what we did here, right? Right. So that should give us a snapped angle. But we're not quite done yet because we have snapped the position and we have snapped the angle, but we don't know the final position of this yet. Because now we've sort of gone from the current Cartesian position of this object, converted it to polar coordinates, snapped those polar coordinates, but then we haven't done anything else with that. So then we need to sort of go from the polar coordinates back to the Cartesian space, because that's what, that's what the transforms use here, right? Right, so we have the distance and we have the angle, and now we need to go back to that coordinate space. So now we can use the same thing we did before with the grid. We can use the cosine and the sine in order to get the direction of the snapped angle, right? So now we're converting from a angle to a direction again. So new vector 2 cosine of oh wait, actually this is not the angle because this is in turns right now. So we need to multiply this by tau. Yeah, this is the angular in radians snapped, right? We could separate those two. That might actually be better. So this is angular turn snapped, but we also need to get that as radians, right? Converting turns to radians, we multiply by tau, right? There we go. And then math.sine of snapped angle in radians. Okay. So now we have the direction to the snapped new position, right? But what is the distance of that one? Well, that is the snapped distance, right? So we have the direction and we have the distance. So all we need to do now is to do the snapped, the snapped vector. Let's call it vector. And then we do the snapped direction multiplied by the snapped, the distance snapped, right? I reverse this. There we go. Consistency. Cool. So now we have the vector that is snapped but it's still in the 2D space, right? We have this in the top-down space of this whole coordinate system, but we don't have it in 3D space, right? So we need to actually get, kind of reconstruct the 3D position. So all we need to do then is that we need to return the final position, which is a vector 3. The x component is going to be the snapped vector.x, and then the z component is going to be snapped vector.y, and then the y component of this one is going to be the original y component, because we don't want to change the height of this, right? Because this is purely a cylindrical, like, polar grid, right? So in that case, we would do the original position dot y. So now we're sort of, this might look pretty confusing because we're sort of mixing our different spaces here, but remember that the snapped vector we were working in this 2D space of just looking at things like this, right? But then we need to map that to the x-axis, which is the first argument, and then to the z-axis, which is the third argument of this position. So that's why we have the y-coordinate of this one is mapped to the z component of the final position in world space, right? And then we grab the original position in world space as well for the y component, right? And that I believe is what we need to do. Also, we need to return, in case it's not Cartesian nor polar, which is currently impossible. Okay, I think I got this right. I'm actually not sure. Okay, are we calling the... Yes, we are. Okay. Is this a good test case? Probably. All right, let's move the manager because it's in the way. Let's see if this works. Snap, and that looks like everything is snapped actually. Snap selection. Yeah. We got ourselves some snapped things. Let's pull it all the way down to 5 and change the grid size. Let's snap. Dude. Cool. Undo works as well. Neat. It works. We did it. We made a grid. There was only one thing left. There was the fourth assignment was to also save these between sessions. Like all of the configuration you have here should also that should be saved between your editor sessions of Unity. Let's do the saving of this between editor sessions. That's probably a good thing to end on. So right now, all the values we have here in the snapper window, we can set this to like 2, we can set this to whatever we want, right? But if I close the snapper and then go back to the snapper, then everything is reset, right? Which you may or may not want, right? It kind of depends on like what you, how do you want your tool to work? In some cases, you probably want everything to reset. In some cases, you probably don't want it to reset. But for the sake of an example, we're gonna now make sure that all of this is saved between sessions, as well as when you close and reopen this, right? Okay. Also, someone just raided. Thank you so much for the raid, Mercenary Mage. Sorry, I've been really bad at reading people raiding. All right, so I don't know how much you saved data in Unity in general. Like, have you written like simple save systems for in runtime for when you have a game? I was thinking about the player preferences. That's the one. We're doing this in all caps. Yeah, have you used player prefs? Once or twice. Yeah, same, by the way. Don't use them very often. All right, yeah, basically, in the editor, there's also an editor prefs. So So you have kind of the equivalent player prefs, but in the editor as well. And these are saved between sessions. And in this case, they're going to be on a per computer basis, right? So if you want to save things per workstation, then using editor prefs for that is super useful. So let's do that. And there's a very handy workflow here because we can use on enable and on disable as the moments where we load and the moments where we save, right? Yeah, so let's do that. So we would have editor prefs dot, is there a hash key? It'll probably load default, right? Will that save even if you open another project and reopen our tool, for example? I think it's, is it per project or? It looks like it's per computer. So it's going to be global for across all Unity versions, I believe. And across all projects. It's going to match it by key. So you should probably make sure that the name doesn't like conflict with a bunch of other things. So in this case, basically we need to, the data we need to save are these three things, right? We need the grid size, the grid type, and the angular divisions. Those are the only configurations we have, right? So let's go ahead and grab those. So on enable, we want to load the data, right? Because that's when we open the window, and then we should probably, check, do we have any saved data? And then that's where we should load it if it exists, right? So I want to get an integer, and then first is the key. So the key is a string, and we should probably name that something that knows that it's the snapper tool, right? Snapper tool underscore, and then the name of this thing, right? And then the default value, we need those as well. In case it doesn't exist, it's going to load the default value. So let's add that later. But then we assign this to all the different properties we have, right? So let's get the default values. So the default is, let's see, one of this is a float. So grid size should be a get float. And then default value, so grid size should default to 1. Oops. Grid type should default to 0 because we're saving the enum as an integer, right? So then we also need to typecast this one to grid type. And then angular divisions is an integer, and the default should be 24. Right, so load, saved, configuration. And then when we close the editor, then we want to save them, right? So then we kind of do the opposite. So instead of get float, we do set float. Let's delete that. So we do set. We use the same names for this, but then the second parameter is going to be the value we want to set it to, right? Yeah, so we have the key and then the value. Let's delete those, and then add our properties there. And again, this one needs to be typecast because this is an enum, so we need to cast from enum to integer, and then we're going to save that as an integer. All right, and then if you want to make this like clean and proper, you should probably not like type these out here. You should probably have like constants or whatever, but it doesn't matter that much in this case. All right, hopefully this works. I haven't done this a whole lot. All right, so let's close this. Let's open it. All right, so let's change the parameters. Let's set it to polar. Change this to, this is 1.5 and angular divisions to It's a weird number. Let's pick a prime number. 7. There we go. Okay, so now if we close this one, it should save. And if it doesn't, I'm going to be sad and then go eat lunch. So we close this, and the window, snapper, and now it's loaded all the values. So yeah, so now it actually saved everything we configured here, and everything looks correct, right? And again, this is going to be between sessions as well. And I just changed my view to 2D. There we go. So if I close this one and save this project, close that, go to Unity Hub. There we go. Now we're back, and then we go to Tools, Snapper, and all the settings are still there. So that's a neat way of saving your configurations across sessions. And even if you close the window and reopen it, you get everything back. Yeah. Oh, someone also asked, can you save its docked position? You can, because that's what Unity does automatically. So the docked position is automatically saved, for better or for worse, depending on how you've coded the plugin. So make sure you code your plugins so that they can open regardless of which scene you're opening. So you don't want to have any kind of dependency for your editor window and the scenes, or some data that might get lost between sessions. So if I close Unity now and then reopen it, the snapper is still going to be there, right? Which is also part of the layout system up here in case you save your various layouts. All right, any questions before we go for lunch? I still have my broken lunch splash overlay. Is there any downside of using editor prefs or player prefs instead of creating a save data writer and reader class? I have never used the save data thing. For games, it's easy for people to just find the file and cheat by changing it. Yeah. I like that. I think that's a neat thing. I think it's fun to, like, as a player of games, I think it's fun when, like, all of that data is exposed so you can sort of, like, play around with it. I think that's neat. Like, sometimes instead of using, like, player prefs for saving, I specifically save things in a text file in the game so that people can edit it very easily instead of like going to the registry to find the settings. But also, like, if you wanna make a proper save system, generally you wouldn't use player prefs. That's more for like very simple basic save systems, or if your game just doesn't have very complex data that you want to save. Otherwise, if you want to save more complex stuff, okay, for instance, heck, this might be a bit more convoluted. I can show you the save system in the project that, where's Fluster? There we are. In the project that I'm working on stream generally, in there I have a save system, right? And the game's called Flowstorm. And in Flowstorm, there's, oh geez, the UI is enormous. So if we go to, where are the levels? No. Scene switcher is epic. Thanks. I made it myself. Levels. Here we go. So in this case, this game has a level editor. So whenever, oh geez, the aspect ratio and stuff, and their DPI scaling is very strange. There we go. So in a game with a level editor like this one, you want to be able to, like, you create a bunch of things in a level, and then once you've done that, you have all of these things that you want to save, right? And like saving this in a player prefs is going to be a nightmare because like we have so many things. We have like every single position of all of these things that I'm selecting right now, all of those are like separate vector2 values. And then we have the checkpoints and the finish line. We have the start point. We have whether or not these are deadly. We have whether or not they're linear. Like all of these different things has to be saved, right? And if we just do that using player prefs, that means that like what are the keys going to be for that in our editor prefs? That's going to be a mess, right? So for anything that's like bigger than just saving very simple data, like things we've done here, then you're probably going to want to serialize that in some other way. So one of the most common ways of doing that is using JSON serialization, where you set up a data type that contains all of your data for the level, or whatever it is that you want to save. If it's a save state or a scene state in a game, then you can use a JSON formatter to convert that to a JSON string, and then you write that JSON string to a file. Unity does have a JSON utility class, which is really useful for that type of stuff. So if you go to JSON utility, this one. So basically it has a from JSON and to JSON, where if you have a class which has a bunch of serializable things, like serialized list of vector3s and a list of some other type that's also serializable, then you can do to JSON. And then you shove the object into the to JSON function, and it serializes all of that in a very, very like nice format that's actually very readable for humans too, especially if you set pretty prints to true. Otherwise, it's going to optimize for small size. So this converts an entire object into a long string that kind of describes the entire hierarchy of your object. And then when you load a file, you can read from the file, and then you do from JSON, and then it converts from that string to your object, right? Which is super useful. And that's what I'm using in Flowstorm when saving these levels. So the levels are here, and let's see which one. Swirl is a big level. Let's select some apps. Where is? Okay, let's do Notepad. Right, so this is what a level looks like. This one is not set to pretty print, so it's kind of unreadable, but you can sort of see how this works. Like, there's a bunch of data for like what version of the game this is, and then you have start position. You can see that it's sort of saved the X and Y position, and then a bunch of metadata, like the Steam ID is useful to have, and then all of the coordinates for everything, right? Now, this one is saved as a string, as text. But if you want to be like even more efficient, you would probably use a binary formatter rather than saving it as a string. But I personally like saving things as strings generally, because then it's readable and it's more easily debuggable, right? Okay, anyway, that was a short overview of how to this, yeah. All right, any questions about that before lunch? Sorry, I went a little bit over lunch. Where are the, oh, they're there. Oh, thank you so much. Is there any place where we could try this game? It's currently, it's sort of half public. I give Steam keys to people who donate. So people who donate $10 or people who support me on Patreon at the same level. So yeah, it does exist. I just manually give Steam keys to people. So it's on Steam, but it's private. So it's not like visible yet. I'm going to set up a store page for this as soon as I have time for it, which I'm not sure when. But yeah, so it's still very much a work in progress, and this is generally what I stream when I stream. I stream working on this game. The thing we recently added was magnets, which is pretty wild and difficult sometimes. But yeah. I need to find a place to put my camera that doesn't do the screen shake every time I hit my table, because it's a little wonky. So now we're gonna make another plugin or another tool for Unity. This time it's still gonna be an editor window, so sort of it's a thing you can open and then configure, and then you can do something. But this time we're gonna do more stuff in the scene view itself, and also work a little bit with hotkeys. So the idea for this one is that imagine that if you have a game where you have the big landscape, and you know there's a bunch of trees you want to place or scatter around the whole environment and so forth. Generally that can like add up, and then there's a lot of things you want to place, right? Sometimes you want to add a bunch of rocks or like other props or whatever. And especially for stuff like vegetation and like foliage in general, like sometimes you kind of want some tool to help in like placing all of those items, right? Like, wouldn't it be nice if there was a tool that could sort of scatter things across terrain, right? So if you have some landscape and you have some tool where you can sort of point to the ground, and then in some region on the ground, it's going to scatter, you know, a number of items in that whole region. So in this case, if it would place a bunch of trees or something. Yeah. So that's one thing that we're going to do. We're going to make a tool for scattering prefabs specifically across you can configure the radius and the amount of items. So that's sort of how that will work. And then the idea is that we're going to use the scene view to select where we want to place this stuff, right? Okay, how does that sound? Does that sound like a neat little tool? And I'm thinking we could have like an array or something where you select the prefabs that you want to spawn. And there are many different ways that we can make this like more or less useful. And it's kind of like expandable because there's a lot of stuff that could go into this depending on like how you want to design the tool. I think the approach that I want to take is that I'm gonna do like, as usual, do like a long lecture about like how writing this tool. And then afterwards, I'm going to give you some things that you can do to expand the script, to sort of add some features to it. Just like we did with the grid, where, you know, we set up the basics and then you get some assignments to expand the script with some more features or change a few things up. All right, so I think that's the plan for today. I don't really need all of these things right now, so maybe do delete them or disable. I don't need the snapper. Right, first off, I'm just going to set up a very weird and simple terrain that we can cast items onto. Oh. Even crack cocaine, I cannot advocate for that as an official Future Games teacher and a Twitch partner. Not doing the terrain tool this time. I don't trust the terrain tool. Look at this grass. Isn't this very idyllic? This is how you make hills. Where's the hotkey? There we go. Z is the hotkey to change pivot point. Wow, what a terrain. This is absolutely wonderful. Neat. All right. There we go. Landscape completed. And then we need to place some items onto this one. So I think the actual spawning of the prefabs can actually come pretty late in the process. So I guess I don't really need the prefabs right now. Just setting up the tool and setting up like where to place them is kind of most of the work of this. So maybe we can start out doing that. So we can draw stuff using gizmos and stuff. All right. so let's make a new editor script. What do we call this one? This is going to be like a prop placer, like a cannon, prop cannon, prop scatter tool. I don't know. Do you students have a good name for it? You could give me like an in-joke that I don't get, and then I'm like, sure. And then you're like laughing together, and I'm just like, I don't know. I simply don't know this joke. Cannon or something? I don't know. Let's call it cannon. Prop. Grim tool. Why does everybody keep referring to Grim? I'm confused. And also the like that emote, I'm so confused by that. But you know what? Let's call it Grim Cannon. There we go. Are you happy, Grim, with the society you've created with your memes? All right, so this is going to be an editor window, right? So we need to go through some of the like usual boilerplate when you make an editor window. So first off, it needs to be inheriting from editor window. And then you also need to be able to type, which is kind of one of the most difficult parts of coding. And then we also need a menu item so that we can open the Grim Cannon, right? So we need a menu item, tools. Tools is usually where I think Unity has like told people who make assets to put things in tools if it's like editor windows. So that's probably a good place to put them. Because otherwise there tends to be a lot of like, if there's like Grim's tools, and then there's another like subcategory and another subcategory, you tend to like get a very cluttered bar up here. So sometimes it can be really important to like try to keep that down to not make it incredibly like cluttered. So tools is a useful one. Right, Grim Cannon, not prop cannon. All right, so this is going to be the thing that opens this window, right? So we're going to do public void and open Grim. There we go. And then we need to call the get window function, and the type is going to be the type of this editor window. So that's Grim Cannon. And yeah, that should be enough to open the window. Oh, right, it needs to be static. Grim Cannon, there we go. All right, so we got stage 1 of this tool. Let's dock it. All right, and then we need a few other things. We need some properties for this one for setting the radius of the thing that you want to place. We also want to set like the amount of things you want to spawn, right? So we need radius. Spawn count. There we go. Okay. Just need to make sure I do this in the right order. Otherwise I might get messy. Actually, it's already, I jumbled my notes. Never mind. It's fine. Okay, let's start out with this. So now we need to figure out how do we, so now we need to do the same thing we did last time, right? Where we need to be able to draw in the scene view from this one. So what we can do is use the same function we used last time, right? Where in onEnable, we sign up to an event that is called in the every scene views GUI event, right? So let's call it on scene GUI or during scene GUI. And that takes a scene view, because this is called per scene view that you have open, because you can have multiple open. So in onEnable, we want to do scene view dot during scene GUI plus equals during scene GUI. All right. Then we do the same thing for on disable. Thanks for the formatting. It's not how that works. Jesus. And then we unsubscribe and undisable. So this makes sure that when we open the window, we're going to sign up to this event. So then this is going to get called by this event. So we're going to get this one called automatically. And then in ondisable, in other words, when we close the window, or if we leave Unity, or rather if we like dock the window or whatever, I think it's going to get disabled. So then we make sure that it unsubscribes from that event. Yeah. Okay, so now we have a place where we can do things in the scene view, right? And that's the big part of this, because now we probably want to be able to somehow specify where we want to place the things, right? Because right now it's kind of like we just don't have anything to help us with that. So let's do, we can start with a simple implementation of this. So let's say we use the scene view camera. Like we want let's say the camera center is going to be where we want to place things, right? And one thing that's very like neat that took a long time for me to realize is that a lot of the things in Unity's editor is built using components that you would use in-game. So this scene view is literally a game object with a camera component on it, right? So we can actually access all of these things and change all the things you would expect to change at runtime, but during edit mode, right? And you can get a reference to that in scene view dot camera. So now we have access to the camera in the scene view, right? So if you want to change the camera field of view, you could do that as well if you would want to for some reason. Yeah, and you can also break Unity totally using this. Like what if you delete the camera component? I wonder what happens. I have no idea. It sounds like a bad idea. Yeah, so here's where we can do all sorts of shenanigans. So let's cache this. Actually, we probably don't really need the camera. It's probably more so that we need the transform of the camera. So that's a camera transform. Also, this is going to be quite a lot. And so feel free to ask questions at any time during this whole thing, because I'm not sure if I'm going to miss something, or if you want me to like repeat something, I can totally do that. It's always better to ask questions if there's something you're like considering asking than to not, and then just never get an answer to that. So don't be afraid to ask questions whatsoever. Okay, so now we have this UI loop and we can get the camera transform. Right, so we're talking about like where to place this stuff, right? And one nice way of like visualizing that would be to show some sort of, to draw in the scene view, right? And last time we were using handles dot draw line and all of that stuff, right? So I'm just gonna make sure that everything works. No. There we go. Wait, what? Why is that not allowed? Right, so now we're drawing this little line here. So that means it's working. Cool. All right, but we want to place things not like at the origin of the world, right? We want to place it where the camera is pointing. So what we're going to do is that we're going to raycast. So we're going to do, we're going to need the array to raycast with, right? So we set up a new array, and that's going to be a new array, and then we need the origin first, which is going to be the camera. So camera transform dot position, and then camera transform dot forward. And then we're going to do raycast. So if physics. So this is like also an important takeaway. Like in the editor, you have access to pretty much every function you would run at runtime as well. You can raycast, you can like do all sorts of stuff that you like might not expect, but like everything you do in the Unity editor is also like stuff that you would use outside of that too, which is really neat. So we can like raycast and everything. So it's kind of like, it's very similar to making like gameplay code, right? Especially for stuff like this where you're dealing with a scene view. So we want to do a raycast, we send a ray, and then we want the raycast hit information. There we go. So if we hit an object, that's when we want to mark the area we hit, right? So let's do that. We can steal this line. So in this case, let's draw that from hit.point and then hit.point plus hit.normal. So now we're going to visualize the normal of the surface. There we go. So now we have this little white line. White might not be the best color for this. There we go. Slightly more visible. It's still very thin. Okay. Oh, wait. Isn't there a thickness parameter to this? Width. Yes. Because the DPI scaling didn't actually scale the lines. Well, that made 0 difference. That's a little bit better. Cool. Okay, that's pretty visible. Neat. So what it's doing now is that it's raycasting from the center of the camera in the direction that the camera is pointing, and then it hits the surface, and then it's drawing a line along the normal of that surface, right? It's a little confusing when it's following the camera like this. Yeah. All right, cool. So now we have some way of like finding out where we want to scatter all of these items, right? Might actually be okay having a white line now that it's a little bit thicker. Cool. So then the next step would be to maybe visualize the radius that we're going to scatter stuff in, right? So let's do that. We have the radius property here, where we have the radius of all the items we want to place. Or the radius of the area in which we're going to place items, rather. So let's visualize that as well. So we can do handles dot draw wire disk, and we're going to need a center, which is hit dot point. We're going to need a normal, which is hit dot normal, and a radius, which is the radius property. And let's go back. And now with this little circle. All right, but we can't tweak this radius right now, so we need to be able to do that as well. So now we're going to add the on GUI loop. So on GUI is for the window GUI here, right? Keep in mind that we now have 2 functions for GUI. One of them is the actual editor window. The other one is drawing the scene view GUI that we got here. And yeah, so keep that in mind. So what we want to do is do kind of the usual boilerplate just to get this up and running and work with the undo system and all of that stuff. So let's set that up. So we're going to need serialized property, and then prop, this naming it prop, and that stuff is kind of optional. It's just that it's a naming convention that I like to follow for properties. And then we're going to need the serialized object, which I just call SO. All right. And then we do the new serialized object with this prop radius. so.findProperty. Then in here, we want the property names. So that's radius and spawn count. And these, again, need to match exactly. And then we want to draw the GUI. And so we do editor GUI layout dot property field and then our properties. All right, that should be it. No, it's actually not. I forgot the thing that I keep telling you not to forget. We need to do scriptable object dot serialized object dot update and serialized object dot apply modified properties. All right. Whew. There we go. So now we got radius and spawn count. And now if I pull radius, it's now going to update. Yeah. And depending on, I'm very picky with a lot of things. I'm going to talk about the things that I'm usually picky about because I think it might be useful. You don't have to be as picky as I am with a bunch of these stuff. So one of the things that I don't like is when things look laggier than they can be. So right now, if I change this radius, it might be hard to tell on stream. It looks like it's slightly lower than 60 FPS. It looks like the editor is sort of updating at, 20 something FPS, right? And that bothers me because Unity doesn't actually have to update the scene view. If nothing is changing, then why update it, right? But you can actually force the scene view to update. So in this case, I can check if something has been modified, right? So if something has been modified, then I want to force a repaint for the scene view. And there's the scene view.repaint all, but I'm guessing we can actually access the specific scene view that we have now. No, we can't because it's on GUI. So scene view.repaint all. So whenever you tweak this property, we're going to repaint the scene view immediately. So now it's way smoother. It's probably visible on stream actually that this is smoother now. I thought it might not be, but yeah, I think this looks really neat and it feels so good. And I think it's important to think about game feel even when you're making tools, right? So yeah, that's just me thinking as a game developer, I guess. But yeah, I like going into those types of details. Then there is one more thing that also bothers me, which is also about game feel, I guess. Can you show without the if case again? Yeah. Here we go. Let's go to darker side. It's easier to tell here. So this is without the if statement. So if I change quickly, it looks like that. If I bring that back, it's very visible on my monitor. I'm not sure how visible it is to you, but yeah. But again, that's me being very picky with frame rate, I guess. So now we have this little cursor thingy set up, right? But we don't really have any points in it, right? We wanted to spawn things at random points within this circle, right? So we need to generate random points. So let's do that. And I imagine the way we do this is that we undo many times. So we fire a ray from the camera, right? So the camera is here, and then we hit some point. The point has a normal, right? So we got a direction, and then using that direction, we can set up a disk, right? That's the kind of the disk that everything's going to spawn in. But since the terrain is uneven, we kind of need to figure out where do we spawn, not only inside this disk, but actually on the terrain beneath the disk. Because that could be somewhere other than the actual point, right? So we need to find those. So what I imagine that we should do is that given that we've set up this disk now that has a, a direction. It has an orientation, right? We can sort of imagine a cylinder where we generate random points within this disk, and then we raycast from like 2 meters above or something, or 1 meter above, in the negative normal direction of the disk, right? So that would raycast down. So we would raycast from all of these points offset from that plane, and then eventually we would hit various points on the ground. So there are kind of 2 steps to this. One is to generate the random points. The other is to offset all of those random points and use those as the origins for the raycasts, which will then determine the actual points that we're going to place the objects at, right? Does that make sense? So these 2 are sort of separate things. So we're going to start out by just generating those random points. All right, so let's make a vector2 array of our random points. Actually, it doesn't have to be initialized. And in this case, we don't actually need to serialize this. We don't need to save the actual random points between, like, it doesn't matter if we like recompile or anything. We don't really have to save these, right? And we definitely don't need to make serialized properties out of it. Although if you do want to make sure that the points are the same after you recompile, it might be a good idea to serialize them. But it's kind of depends on how you want to set it up. So in this case, I'm just going to not care about that. So we have our random points, and then we're going to need to determine when do we generate the random points in this, right? And it's a vector2 in this case, because I just want the 2D coordinates, the coordinates within the coordinate system that is the disk, right? So that's a 2D point. That's why it's a vector2 rather than a vector3. Okay, so what we can then do is make a function to generate these random points. So let's make a generate random points. And then we do random points equals new, not like that. New vector2 with, what do we call it? Spawn count. There we go. We can make an extension for random vector2. You could if you want, but that already exists, so I don't know, you don't really need to make an extension method for that, unless you want to make an extension method for like vector2 arrays. But because what we're going to do is a very straightforward for loop, and in that one we're going to go through spawn count, and if you want to get a random point within a disk, then you can do rand points I equals math dot, or actually it's in vector2, I believe. No, it's in random. There we go. Unit engine random dot inside unit circle. So that gives us a random point inside a unit circle, and that's exactly what we want, right? So that is a vector2. Right, and then it might be a good idea to draw these. So let's go back to our raycast here. So we're drawing a disk, and then let's draw some points. Also, we need to determine when we're going to generate these points. So I'm just going to put this one in on enable for now, which I think should be called there. Okay. Great. So now we sort of had the same problem we had before when we were looking at the cross product. I don't know if you remember, but we had a case where we were shooting a ray onto the ground, and then we can find the normal of that. But sometimes you need a full like orientation for that, right? Like you hit the ground, and then you get the normal, which is usually the z-axis, and then you're asking, well, what are these other two vectors, right? So what we need is a full-on coordinate system for the point you hit, right? So that would be the next step, because now if we have these points in 2D space, that 2D space is relying on these two vectors existing, but we just don't have those right now. We just have the blue one. So yeah, so we need to set that up. And how you set that up is kind of, it depends on how you want to do it, I suppose. It can be like if you want it to always be aligned with the screen or whatever, you can do that as well. So yeah, it sort of depends. So let's set up some vectors. So we can call it like the coordinate, or what do we call it? Spawn space, reference vectors. Let's call it reference. So reference vector on the z-axis, that would be hit dot normal, right? So it's hitting the surface, and then we get the blue vector here. That's our normal. And then we need to construct the rest of this coordinate system. So let's see, what could we use as a reference vector? We could use the up vector of the cross product between the forward vector and the normal, I think might be a good other axis for this. So vector 3 dot cross between the rev z, which is the hit normal, and then we're gonna need, actually, let's call them normal, hit normal, because then we can use the other terms for this. So if you're talking about like a surface, this is very useful information if you're ever doing like shaders or any like physics, I suppose. The blue axis is generally called a normal if you have a surface like my hand right now. So the blue one is a normal, and the other two are tangents to that surface. So because they're going along the surface of my hand, right? So generally the red one is called tangent, and then the green one is called a bitangent. Yeah, so it's useful to know, because then you have the a tangent space coordinate system is what this would be called. So if you've ever used like tangent space normal maps, which is the most common type of normal map, then they would use this space, which is a specific space for you know, aligning with the surface and moving along with the surface. Yeah, good to know. So we could actually technically call this whole thing tangent space if we want to. All right, so we're gonna hit the surface, and then we do the cross product between the, let's see, the forward vector. Trying to figure out which should be which now. I think normal and up vector of the camera and the normal would give us something neat. No, actually, let's use the forward vector. Sorry, I'm so indecisive. I think this is a bitangent, depending on the order of the arguments we do here. So then we need the camera transform dot forward. All right, let's think about this. I want to make sure I get the terminology right. Did get my water bottle right. It fell. So we have the normal of the surface. That's a blue vector right there. So that one is pointing that way. And then we have the forward of the camera, which is pointing that way. So we're doing the cross product between those two. So that gives us a vector pointing right, which could actually be either. It doesn't really matter. Let's call it the tangent then. All right, and then what we talked about last time and during the math class is that when you do the cross product, the whole idea of doing the cross product is that you get a vector that is perpendicular to both of these, right? To both of the inputs to this one. So practically what that means is that we get one of the other axes of this coordinate system, right? And we also need to normalize this because it can actually not, most of the time it's not normalized unless both of the inputs are normalized themselves and orthogonal, right? All right. And then we need the final vector, which is we have the normal, we have the tangent, and then we need the bitangent, right? So to get that one, let's see. This is going to be some cross product shenanigans. So we have normal and tangent. That's the blue one and the red one. But we also need the green one, right? So if we do cross product between like that. Yeah. So if we do cross between... Wait, you got an add? You should not have gotten an add in the middle of the thing. Okay, so if you do the cross product, if you look at the coordinate system, and the cross product is if you pass the red one and the green one, you get the blue one, right? So that's what we want to do here. We have these two, or rather we have these two, but we want the green one, right? So if we take the cross product of the blue one, and this is very convoluted and confusing, and the red one, we get this one, right? So in that case, I'm just making sure that I get this in the correct order. So then it would be the normal and the tangent. And these two are orthogonal. We know that these are perpendicular, so we don't need to normalize this one, right? Okay, sorry, thanks. I forgot to change. So the thing I added was that we're now doing the cross product between the normal and the tangent to get the final vector. We don't need to normalize that one. And I just want to make sure that I got this right. So I want to draw lines with these. I wonder if there's a never mind. Okay, tangent, normal, bitangent. Should see a coordinate system now. That does look like a coordinate system. It does rotate a little bit. I think we would need to use a different reference vector if we wanted to not rotate. Because now we use the camera forward as a reference vector, but if we use camera up, then now it's sort of, now it's a bit more predictable, I feel like. Because the x-axis is now aligned with the camera, right? That's probably good. Neat. Another ring is blue, but you know what? That's fine. I'm okay with blue rings. And I will say that publicly. So now we have a space setup. So this is basically setting up tangent space. We don't really need to draw these. I guess we can remove them later in case you want them to stick around for a bit. So now we've supposedly already generated our random points, right? But we're not actually using them for anything. So let's use those. Let's iterate through all of those points. Random points. Oops. And then we can do handles dot draw sphere handle cap break time. Right, let's go for break right after this then. So handles sometimes have a lot of like functionality that you might not always want to use. So sphere handle cap is like meant to be used as like a draggable handle type of thing. But you can also use it just to draw a sphere, although it has a lot of like boilerplatey functions that you probably don't really care about. So yeah, if you want, you could set up like a helper function for that, which I want. Draw a sphere. All right, so it's asking us for control ID, which doesn't matter. It's asking us for the position, which does matter. Quaternion identity is going to be our rotation always. Size, we could hardcode that. And then event type. Then we probably only want this to be happening on Repaint. All right, now we have a simpler draw sphere function, so we don't have to do all of the boilerplate. Draw sphere, P. Although now this one is in its own coordinate system. So these points that we have here, they are defined in tangent space. They're supposed to be defined in this space right here, but the draw sphere function wants a world space position. So now this one is like placed. Oh, it doesn't paint if it's not drawing the thing. But yeah, so these are now being drawn at the origin of the world, right? Which is very incorrect. So what we want to do is we want to transform those. There are various ways of doing that. We could set up a rotation and transform by that rotation. We could set up a matrix and transform by that matrix. We could also manually do it by multiplying each point's axis by either of these vectors. It kind of depends on, like, I don't know what you would prefer to use, but the sort of proper way is to set up a matrix, because that's the most portable one, but you don't always need a full-on like matrix transformation for everything. So anyway, but we need the world space position, right? So this is going to be world position. So one way to think about this is that we want the, first off, the hit position is the origin, right? And then we add something to that. And then we can use the directions we have here to draw the point. And in our case, we want the tangent and the bitangent, right? Because remember, the tangent and the bitangent is the red and green vectors, and the blue is the normal of the surface. And the disk is around the blue vector on the x and y plane, right? So we want the tangent multiplied by the point's x coordinates plus the bitangent times the y coordinate. And that gives us a world position at this point. So now we can delete that and go back. So now we transform these into world space from tangent space, right? So now we have these little points here. But then we also want these to be distributed within the radius of this thing, right? But right now they're just kind of clustered in this little weird area in the center. So one more thing would be to also scale the position. So that would only apply to this part. So we can multiply that by the radius, right? So recompile. Now we got some new points because onEnable is being called in this one. But now we can change the size of this one, and we can see that the points sort of change with it. what does tangent space mean? So generally when you talk about tangent space, it's quite often, at least when you work in shaders, tangent space is sort of a space that doesn't have any origin. So say you have a curved surface, then you can sort of set up a coordinate system on that curved surface, kind of starting out with a normal, right? That's what we've been doing now. And then you would have tangents to that surface. So tangents are usually red, which means that I picked the wrong color for this surface. There we go. So you could find a normal of the surface, right? And that would be one axis of your tangent space. And then you would find another vector that is tangent. In other words, it goes along the surface instead of being perpendicular to it. So this would then be, actually, I guess would be this one. So this would then be the x-axis, and then the y-axis would point away from the camera in this case, depending on if it's a left-handed or right-handed coordinate system. So the green one would point like away from the whole thing, if you imagine all of these having the same length. So sort of the difference between like local space and tangent space are kind of just terminology, but what is unique to tangent space is that it's always specifically aligned with the surface, right? And if you are like drawing a normal map in a shader, or rather using a normal map in a shader, then you're going to have a unique tangent space for every pixel that you want to render on, right? Because the tangent space is going to keep rotating like this as you go along the surface, right? So the tangent space isn't actually something with a real origin. You mostly use it to transform directions rather than positions, right? Yeah. In our case, we could call it a local space as well, because we are using it for lots of different things now. But generally, the concept of a tangent space is just a space that is tangent to the surface in some way, right? And to some extent, you can sort of see these as different spaces, but in shader code, you would write them the same way. So it's kind of like vague how you want to like use the terminology there, but yeah. But yeah, the tangent space is a space local to some, some orientation of a point of a surface, right? And quite often it can actually be kind of ambiguous, because if you imagine that you have a surface, right? Like say you have my hand, and this would be tangent space of one point of my hand, right? It can be pretty ambiguous. Like, what is the rotation of this one? Because a normal is not ambiguous. The normal is like the one thing that you know is the normal of the surface. But there are an infinite number of tangents to the surface. So then the question is, what is the orientation of this, right? This is quite often... in your 3D programs, they quite often align it with your UV space. So what happens is that when you export the mesh, you can export tangents on each vertex in addition to normals. So then what you have is that you have these two vectors, and then the green one can again be calculated using those other vectors. So then you have that extra information of the tangent, right? So then the idea is that the tangent is generated based on your UV coordinates, which usually help determine the orientation of them, right? Because when you're making normal maps, you want the normal maps to be aligned with the UVs, but the UVs also have to be aligned with the tangent space of every given like texel that you're rendering, right? You need bitangent and tangent so you can rotate and align the prefabs to the surface. Right now, we haven't gotten into that yet. We needed them in order to get these random points within the circle, right? You have a unit circle, right? This, and it has a radius of 1, and we have a bunch of points inside of that circle. And so then you have these coordinates, and each of these have some position. So this would have something like x coordinate of 0.5, and a y coordinate of 0.1. And then the question is like, how do we translate from this to a position in the world that is aligned with this disk, right? So what we can do is that we can set up a set of basis vectors or a coordinate system, which in this case would be similar to this, right? And that's what you can see. That's what you can see in the center of this disk. That's our coordinate system that we can use to transform from this like normalized 2D space to a world space position here, right? I'm surprised Raycast doesn't provide such data. So the thing is that like it's ambiguous, right? Because there's not one tangent space when you hit a surface if the only information you have is the normal, right? So that's kind of why Raycast doesn't give you that information, because there's no such thing as a tangent that is explicitly defined, right? So if Raycast did provide you with that data, then that means that Raycast made a decision for you on how to align that space. And I think a lot of people wouldn't want that, and it's also not free to calculate that, right? Wouldn't it be better to only calculate the world position of the dots when they're actually changed and not on every draw? You could do that, but it doesn't really matter that much in this case, right? Like, it gets complicated because, like, you want to update the drawing when you move the camera. So that becomes your metric for when you need to update the point positions and whatnot, right? Yeah, so actually the point at which where we need to like get the world position of the points is when we're drawing the scene view, right? And we could get like super picky about like, you know, only when changing very specific things and only when we have to, we update them. But in this case, it's kind of like, we can optimize very specific edge cases, but if the worst case already has to be optimized, then we can just like, whatever, we can just like, to keep drawing them whenever. And it's not a big overhead in this case. This is a very, 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 very cheap transformation, unless you have like 1,000,000 points that you want to spawn at, right? Those little white dots for the spawn points supposed to update when you alter the value. Right now they don't, but yes, they will. We haven't talked exactly about when we want to update them. I'm being a little conservative in when to tell them to update, right? Because if I tell them to update every time we draw them, that means that they're just going to flicker because they're going to draw every frame, right? Or they're going to update and change every frame, right? Yeah. I thought I missed a trick. No. But what you can do is that if you change the spawn count to like 16, and then you recompile your scripts, then I'm pretty sure they're going to update. Yep. So the reason that happens is because on disable and on enable is called in your in the editor window. And it's in on enable that we're currently updating the points in. Speaking of inverting like this, I remember this like, I don't know where I read it, but there was somewhere where someone was like, there was someone who posted somewhere who was asking, oh yeah, they were asking, why do mirrors only mirror horizontal but not vertical? And I thought that's an interesting puzzle to like think about, because then you're like, yeah, I think it's interesting. Just thinking about that and then like trying to realize where the reasoning or the question, like, is it flawed? Does it actually mirror horizontal? What does it mean to mirror horizontal versus vertical and so forth? I think it's a funny question. Someone redeemed cat ears. I'm only going to do that if that was a student. Oh, it was a student. Okay. Do I put on cat ears? Is that a professional teacher thing to do? All right. Hope you're happy. Imagine the people returning from the break not knowing that you did all this. Just like, oh, how did that happen? There we go. It's me, your furry teacher. Oh no, the students are deleting the evidence that they redeemed the Jesus Christ, that's... Wow, okay. Okay. I see how it is. All right. Hacking, deleting evidence and whatnot. You're going to make everyone think this was my idea. And no, I am not going to do a video on observer patterns. I am sort of like... I have a grudge against design patterns in many ways. So yeah, for many reasons. First off, I don't even know what observant pattern is. And I don't really usually do like videos about very specific topics like that. I generally do like long form introductions. But yeah. Um, but yeah, no, I don't know. I usually find that like most of those types of most of the types of design patterns that I see for code generally tend to solve one problem extremely well, but they fuck up your workflow everywhere else. That's like 90% of all the like patterns I've seen. So I just like, I feel like I just don't care that much about patterns. I've like never seen a pattern that's like convincing to me, except for the ones that I'm probably like already using without knowing it, because I just don't know the terminology. Excuse the F word, but sometimes that happens on this stream, but I have opinions. Yes. Oh, right, I'm talking to the programmer students. I'm sure there's people who disagrees with me on that point now. All right, should we resume? Are we all ready? Are all the students in place? I guess our 2 weeks of design patterns lecture can be ignored then? Yes, ignore all of that. That is hot garbage. It would actually be kind of interesting to talk to your design pattern teacher about that, because I have opinions about this, and I feel like so far nobody's been proving me wrong. So yeah, bring it on, the other teacher, debate me on stream. Hey, don't ping the teacher. Oh geez, are we gonna have a like after school? I'm gonna meet that other teacher like on the yard, and we're gonna have a like one-on-one. Whew. Are you placing bets? All right, my bounding box has changed, so I need to slightly tilt my camera up. Oh no, the other teacher is here. Oh geez. Oh no. This is bad. I'm gonna get yelled at. Hop on Discord and we can have a live debate. That's gonna be the next thing until break. I lost track of myself because I kept thinking about debating someone who's pro design patterns. Right, okay, so we have our points and we can change the radius. Right now we can't like actually change the spawn count though, so we might want to do that. Because right now if we change the spawn count, it only updates when we like, when onEnable is called, right? So we would want to update that, right? So we could do that here, right? When we change any property, then let's just update all the random points, right? So we could do generate random points here. So then that should update all the points every time we change something here, right? So now we change spawn count, it's going to update immediately. So now we have 99 points in this one. Yeah, it's also going to change with radius, but maybe that's fine. Otherwise, if you want to make it only change for the spawn count, you could like look for a change here. Like if, you know, if the value changed, then only update those. But whatever, I'm just going to do it here because it's easier. Okay. Neat. So far so good, I hope, right? No questions about this so far? Oh, it's starting to lag at 500 points. 600 points, now it's very sad. Did you fix a negative value ref exception? Nope. Let's do that. Because I got sidetracked. So we want to make sure, actually we want to make sure radius is not less than some value as well. So we could do prop radius dot float value equals math dot max, and we want to have a minimum value of like 0.1 or something, or maybe even 1 meter. Like it says tool for scattering items, and if it's for vegetation and stuff, then might as well keep it pretty high. Otherwise you're just going to see this little tiny circle and you're going to be confused. Kind of depends on the scale you want to use this tool at. And then we use the prop radius dot float value. So here's something that I sometimes do. So let's actually do that. Here's some extension methods that I love to use because they make things more readable. So let's make an extension method, public static float, and I'm going to call this one at least, and it's going to have this float v and float minimum value. And then we can do return math.max of v and minimum value. There we go. So now, instead of doing this whole thing, we can assign it to this value, but we want to make sure that it's at least 1. I think that's kind of a neat little way of making things a little bit more readable, rather than just having this esoteric max code that sets a minimum value, which is kind of confusing. Don't want to do the same thing for the spawn count, although in this case it's going to be the int value, which doesn't have this extension method. So let's do that. I wonder if we can do this in Desmos actually. Oh, we can. Okay, neat. Yeah, in case you want to see how this works, because the logic of it can be a little confusing. So if we have a function like x, now it's just returning the same value we have, right? But then we might want to have some minimum value. So let's say that's the red line here. Like, we don't want this purple one to ever go below this function, right? Or below this this y coordinate, right? So the way this works is that if we get the maximum of the current value and then the threshold that we set, you can see that now we can sort of set the minimum value that this one can have, right? So this is sort of like, yeah, that's the logic of this one, where if you don't have this max function, it's going to like keep going to negative values. But if it says max, it's going to pick the bigger one of this two. And then it's going to ask, you know, what's bigger? Is it 0 or is it 2.5? And then obviously it's going to be 2.5. And then that's how we've now created like a minimum value for the radius, right? So even if the input is -10, it's still going to have a radius of 2.5 in this case, right? Yeah, so that's kind of how that logic works. And I find it really confusing that you use the max function to set a minimum value and you use the minimum function to set a maximum value. But anyway, that's just how the math works. But I think it's kind of neat. Very often used in shaders. I almost never see it in gameplay code. I usually see people using clamp functions or whatever. All right, where were we? So we did not finish the code for that. Let's see, we set the float value, we set it to at least 1, spawn count at least 1, that's fine. Okay, so let's see if that works. So spawn count now stops at 1 and radius also stops at 1. It does get a change detect though, because it keeps like regenerating the points even though it's still stuck at 1. What's the next thing? Right, so now we just have points inside of this circle, right? But one problem with this is that this one, we can actually get points that are like beneath the surface, right? Like right now, they're like rendering on top of everything. But we could, like last time, we could make sure that the handles use z-testing. So we set handles.z-test to compare function less equal. So now it should be easier to see that these are actually going underground, right? So that's a problem. And then another problem is that they can hover in the air. So do we have a, whoops, we don't really have a small sphere. Let's make a small. Doot. So if we go onto this one, there are a lot of points that are just hovering in the air, and that's not where we want to place objects, right? We never actually did the raycast we were talking about earlier, where we wanted to find the points above this plane and then raycast down onto the surface, right? So that's the next step we want to do, because right now these are just not valid positions for anything. Okay. So we set up our tangent space, and then here we're just drawing the points. But instead of just drawing the points, this is where we could start doing the raycasts, right? So this world position in this case is actually, let's use that to define a ray origin instead. And then we need a ray direction. And the ray direction is, again, it's going to be the negated version of the normal, because we want it to point in the opposite direction, right? Which in this case is going to be the hit normal, but we're going to negate that. So negative hit normal. All right. And then we're going to need to do a raycast for all of these, right? So if physics.raycast, and then the origin of this one, right, we need to set up the ray. Sorry, I forgot about that. There we go. Point ray, and then we need the out parameter for the actual hit information, right? Raycast hit, and that's going to be the point hit. There we go. All right, so now let's draw a sphere at that point instead. We could also do draw the normals for that. So that would be point hit dot point hit dot point plus point hit dot normal. All right. Let's see if that works. There we go. So now you can see that these are all smooshed to the surface. We do still have one problem though, is that if we go through the surface, they're not going to be on top of the surface here. They're just going to disappear into it, right? Because we're not actually raycasting from a valid position there. So to solve that, we probably want to add some sort of offset for how far away we want to raycast from. Let's see. So we would want to set an offset for this offset here, where the disk is projecting from up here instead of from down here, right? So all we need to do there is that we need to move the ray origin along the normal, right? So we can do ray origin plus equals hit normal times the distance we want to move, right? So let's say 2 meters in this case. So that's kind of like our offset margin thing. Thing is an important word to add there to that comment. So let's recompile. And now we can see that the points are sort of moving up instead. So that's sort of working. So now they're sort of like traversing the thing there. Yeah. All right. Did that make sense? Are there any questions about what we've done so far? This is so neat. What good normals. Could you do that with a circle too? Offset it or draw it along the surface? Someone's lost. What are you lost about? We can do that, but that means that we would need to manually draw that circle by raycasting along the edges of that circle, right? It's possible, but yeah. It would take a bit longer, but not that long. I could do it if you want to. The at least stuff didn't work. What about it didn't work? Where you're calling them, or the functions themselves? Someone on Twitch chat asked if we said that the distance to the camera would be a good offset. So one of the problems with that is that you don't want the margin to be a very big offset, because if you have something up here, you don't want things to draw on top of this sphere, right? You want to be able to draw under things. So the bigger this margin, the more error prone it can be, right? A more advanced version, I guess, would be to raycast upwards to see if there's something above you and use that as sort of a margin. But yeah, so it's like, it's a little complicated depending on the situations you have. There are several things we can do to improve this. Like there are a lot of things that we could do to improve this, but we have a pretty good start, I think. I should probably comment a few things here as well. There's one more polish thing. I mentioned that I like to look at like tiny details, like the frame rate when tweaking values like this. There's one more thing that bothers me a lot when it's not actually fixed. Is that you can see that when you select a field, the things go blue, right? Because it's the highlighted thing. But if I click below, it doesn't deselect it. And that makes me sad. So I'm going to show you how to fix that. So in the on GUI of the actual, like the UI of the editor window, what we need to do is that we need to detect a click, right? And we've talked a little bit about the event system. So you would use the event system for this as well. So if event.current.type equals event type dot mouse down, that is, if you clicked during this event, we could also add another one to make sure that it's left click, which would be event.current.button equals 0. So this is basically saying if you clicked left mouse button in the editor window, then we want to select nothing, right? So so then we can do GUI.focus control, and then just adds null. Whoops. So now this one is going to remove focus from the UI. So if we go back to Unity, now we have these selected, and then if I click outside of that, it's now defocused, right? There's one more thing though. If I click here, you can see that there's a delay in defocusing that one. And that delay bothers me. So one more thing you can do is called Repaint. So this is going to call Repaint on the UI. So this is the window UI, right? The editor window UI. Yeah, so we go back here and then recompile. Now if I click, it's going to like deselect immediately. Yeah, so important minor tool polish, game feel, tool feel stuff. It's hashtag tool feel is now a thing. Yeah, so you can imagine how many things like this I did in ShaderForge, but yeah, there are so many things you can do to like make every little corner of everything feel a little bit better and be a little bit more useful. And yeah, I think it's really important. Okay, so now we got a little bit into the event system. So like I said, the UI functions, the immediate mode UI they have various events, and they're going to call all the code in your UI functions with different event types, sometimes across a single frame, depending on what you're doing. So these events have your mouse inputs, they have your mouse movements, they have your keyboard inputs, they have all of that stuff. So anytime you press a key, there's a UI event being fired off. Yeah, so right now we're just specifically checking if there's a mouse down event with the left mouse button, right? Okay, so what else can we do? So one more thing that would be really useful in this tool is, what if we made the origin of this one follow the cursor instead of being in the center of the screen, right? So you could sort of like, instead of being a thing you move around like this and then you click a button in the editor window, what if you move your mouse to select where and then you click to place items, right? Wouldn't that be neat, right? So let's look into doing that. So then what we need to do is figure out where is the mouse, right? And this is like, if you want to do this properly, this is actually more complicated than it might seem at first, because right now we are, when we're in this function where we're drawing all of these things, we are getting the mouse position of that and then translating that into the camera space gets complicated, because there's like, at best, you have one that's like a little bit offset. And that's frustrating, but luckily there's a built-in function for that where we can find, exactly the cursor position. This doesn't look like it's inside the radius. It's kind of like an infinite cylinder extending in one direction. So it's gonna like shoot downwards, right? Or to the left in that picture, right? Okay, so basically we need to get a ray position, right, from the mouse position. So there is a useful function for that. That is in handle utility dot GUI point to world array. This is super useful. So this one kind of does all of that for you, which is really nice. It used to not exist, and I kind of learned about this recently. That's why I'm like extra excited and talks about how useful this is. Because otherwise you would use like the scene view dot camera dot viewport points to array or whatever, and then that one is slightly off and it's like weird. But anyway, GUI point to world array gives you the thing you want, right? And I do believe that this one wants the UI mouse position and not input.mouse position. So that would be event.current .mouse position. And then this would be array. So instead of using the camera now, we're going to use the mouse position. So now you can see that this one is sort of following the cursor, but not always. And as you might guess, this is because the scene view doesn't repaint at all times, right? So we wanted to repaint if you actually move the cursor. So now we're going to get into even more events like this. So if event.current.type equals event type mouse move. Then we're going to do scene view repaint. So now it's repainting every time we move the cursor, right? So now we got this little thing that is actually following the mouse position. All right. All right. Cool. So we got that down so far. What else do we want to do? So one thing that might be very useful is that if you are in any kind of like drawing tool, like let's say I'm in Photoshop, right? If I'm in Photoshop and I want to change the size of my brush, right? I want it to be large, or if I want it to be small, then if I want to change the size of that, then it's kind of frustrating to have to go up here, right? To like go to some other UI and then change the size. Much like changing the radius of this one. It's kind of frustrating to have to like go all the way over here to change the radius. So what we could do is that we could add some events to this where we can do that using our mouse wheel instead. And we can also do that in this UI code. So let's add functionality for that. So the way to do that is, again, we check event, dot current, dot type. And if that equals event, event type dot scroll wheel, then we want to change the radius. Right. So, let's see, is there anything else I need to check? I don't think so. Okay. So then after this, now we know that we did scroll, and then we need to know what direction did we scroll in, right? So we can do float scroll direction, and we can get that using event dot current dot delta dot y. It's a little bit esoteric that it's specifically delta and y, but event.current.delta essentially contains the change that happened regardless of what type it was, right? So I'm pretty sure if you're in the mouse move event, event.current.delta is going to tell you how far did the mouse move since the last frame, right? So in this case, we're checking the delta of the scroll wheel, which is how much you're scrolling, right? And to make things a little bit easier, I'm just going to do I'm going to get the sign of this one, because I just want to get what direction is it scrolling, but not by how much. I kind of want to control that separately, at least right now, because this one, I don't know if this one is like massively huge values or if they're tiny values. So this one kind of makes sure that, well, it's either going to be -1, 1, or 0. Okay, so now we get the scroll direction, right? Then the next step is that we want to change the radius of the thing when you're scrolling. So what we can then do is that we have our radius, right? Radius. I wonder if we should do the correct way first or the incorrect way. Let's do the correct way. Excuse me. So now we're actually going to change the properties again of this window, right? We want to change the radius, but previously we've done that using property fields, right? So if we want to change that now, then we should probably do that using those serialized fields, right? So then we need to do, again, the scriptable objects update, and then make changes, and scriptable object dot apply modified properties. And here, whether or not you want to undo this, this is kind of a design question. Like if you scroll the mouse wheel to change the radius, should that be an undoable action? I don't know. In this case, I'm just going to let it be that. That's kind of the whole advantage of doing it this way anyway. So, all right. So what we're going to do is that we're going to set the radius property. We're going to modify that one. Actually, we're going to multiply. No, we're going to add. We're going to start by adding, and then I'm going to show you why you should multiply instead of adding. So we do prop radius plus equals the direction you're scrolling, and then we probably want to set this to some smaller value, because now it would be in 1 meter increments, so then it's 1 meter per scroll. So maybe we want to change that to something a little bit smaller, right? We also want to change the float value of the prop radius, right? Okay. There we go, recompile. So now, it is very hard to see if this works. So let's change this to 1. now you see that if I scroll, the radius changes, right? But we have some problems, as you might be able to tell. And the problem is that the UI doesn't update. That's the problem. We need to update the UI, right? So let's let's do that. We can call this is the scene GUI, right? But we need to update the GUI of the Grim Cannon editor window. And I know there are other problems. I just want to fix that too. So we call Repaint, because again, this updates the editor window. Updates editor window. Let's go back, because it's nice to be able to see the radius change in real time, right? So now you can see that the radius is actually changing. Okay, so we have a problem. The problem is that the viewport is scrolling and is changing the distance, right? So now we get into the whole tricky area of like, who gets to choose, who has priority of whatever input you have. There is a built-in system in Unity's UI, whole UI system, where there's the concept of consuming events. So one thing we did earlier, if you remember, we made some code where if you deselect something, or if you click inside of this editor window, it deselects, right? But if you click something here, it doesn't deselect. But we didn't really tell it to do that behavior, right? We didn't say, you know, if you click outside of something, then you should deselect. We just said, if you click, then deselect. The reason it behaves the way we want it to is because, let's find our UI function. The reason it behaves the way we want it to is that event.current.type can be consumed, as in if there are some other fields like property fields here, they can tell the UI system that we're going to consume this event, and from here on it's not going to be mouse down anymore. From here on it's going to be set to event type.none. And that means that it kind of ate that event, and that means that none of the other things are going to fall through, because all of these have already picked up the action of clicking. So we want to do exactly the same thing, but in the scene view, right? We want to be able to scroll and then consume that event and then tell Unity like, hey, this is not a mouse wheel event anymore. Don't scroll. We're just changing radius, right? So the way to consume an event, let's see, where is our scroll wheel? So we want to consume that event. Event dot wait, heck, now I totally forgot the function for consuming event. Oh right, it's event dot current dot use. So if you call this one, we consume the event. Don't let it fall through. So then that means that any other events after this one is just going to be event dot none, right? Okay, let's see if that works. So now if I scroll, it no longer zooms the window. Isn't that neat? But now we instead have the problem that we can't scroll in the window anymore to zoom out. And that might be a problem, right? A lot of people might use the scroll wheel in the editor window, which is not super great, right? Because now I can't zoom in using the scroll wheel. Now I need to use the right click instead. So let's fix that after the break. Wow, wasn't that like a smooth segue of like, just like you didn't see that break coming, but now we got it. 10-minute break. All right, so now we added the scroll wheel, right? But we have a bunch of problems. So one of them is that we can't like use the scroll wheel for anything but this one right now, right? And that's a problem. So let's fix that. So I think one way of solving this, you could argue that you should just never use the scroll wheel in a plugin, but for me, I'm just like, whatever. There are some cases where that's fine, right? So let's pretend this is one of those cases where that's fine. So let's see, where is our scrolling? Here. Okay, so here's where we detect the scroll wheel, right? So if we think of a case where we want to do this is something where like you're not moving the camera, you're just like pointing the cursor somewhere and then you're scrolling, right? But if you hold Alt, that's kind of the button you hold to move the camera, right? or if you hold right click or whatever, if you want to move the camera like this, maybe during those events, we can tell it to, you know, while you're holding Alt, don't change the radius, right? So let's implement that. So then we need to detect, you know, are we holding Alt? So bool holding Alt. So in this case, there is a thing in event, again, event.current.modifiers. So modifiers is a Bitfield. Have you used Bitfields before? Or like Enum flags? All right. So basically it's a pretty simple concept. So you're probably familiar with like how binary numbers are stored. Like if you have like an unsigned integer, for instance, then you would have either a bunch of zeros or a bunch of ones sort of stringed together like this, right? And they can only be either 0 or 1. There can never be anything else, right? Yeah, so in binary, you now in terms of like bit fields, then you know what the numeric representation of that actually doesn't matter whatsoever. So what happens in this case is that you have these bits. There we go. And it might look something like, you might say 0, you might say 1, and 1, and 0, and so forth, right? So in a bit field, you, what this then can represent is that each of these bits represents whether or not a single key is being held. So you can actually make this, I want my color. There we go. So what this is in this case is that the event.current.modifiers contains a bit field that is basically just a single integer describing the state of all of your modifier keys with a single number like this, where every binary, what's it called? Binary digit, I suppose, represents one of the keys. So this, for instance, could be control. And this could be Alt. And I don't know the actual order of these, so don't take my word for this. And this could be Shift. And then maybe this is like right control, and so forth, right? So each of these would represent one of the modifier keys that you have available. Quite often, if you make, which I think is the case here, if you make an enum field, there we go. If you have an enum of things, let's say we would design this, right? We might have our Alt, we might have, actually, let's do Control Alt Shift. There we go. So if you want this one to sort of be a bit field, then you kind of need to assign numbers to these to tell, you know, what is the actual position of all of these in this bit field, right? So control is 0, alt is 1, shift is 2. And then as we go, no, wait, it isn't. Yes, it is actually. No, wait, hold on. I'm getting things confused. Oops. Oh, you've had a similar example? Control is 1, because control would be, if you want a value that represents if control is held, you would want all of these to be 0, right? So 0, 0, 0, 0, 1 would represent control. So that's a value of 1. Alt would be a value of 2. So this would be control. And then alt would be 0, 0, 0, 1, 0. And there's also like more digits here. So, so this would be alt. And that's 2. And then when we get to shift in this case, keep in mind that it's not 3 here. So this would be 4, because it's a power of 2 series, right? So if you add, you know, more of these, then it would be 8, and the next one would be 16, and the next one would be 32, and so forth. Then each of these would represent the number that only has a single bit assigned to it, right? Where you have shift would be ... 0, 0, 1, 0, 0. So that would be shift, and so forth. Okay. So what we can do using this information is that we can combine these in interesting ways to like check whether or not a single bit is set or not set, right? And so what you can do using these would be like modifiers, is that, oh, there's actually a really neat attribute in C#. If you mark these as flags, then if you do print of, wait, does it, yes. So if you then print, if you do like toString on an enum of this type, it's actually going to show you all of these separate names and if they're set or not set, which is super useful. But it could also be just a single integer represented as this. You don't really have to use an enum for this. Anyway, so what's my point in talking about all of this? Well, so this is pretty much exactly what event.current.modifiers is. It is a bit field containing the state of all of your modifier keys. So now if we want to check, are we holding Alt, then we can sort of think about like, okay, what kind of like, what do we need to check to see if this one is 1? Yeah, so the way that I would do that, there might be like faster ways of doing it or whatever, is that if you take the bit field and then you do an AND operation with this bit field right here, which is the Alt one, that means that it's going to look at every, compare this one to this one, this one to this one, this one to this one, and so forth, right? And it's going to use an AND operation. That's an alpha. There we go. So AND is going to set the bit or the result of this operation to only be 1 if both of them are 1, right? Yeah, so what that means is that if Alt is being held, then you're going to have a 1 there in the result of this, right? If Alt is not held, it's equal to 0 because everything is 0. Because if this one is 0, or rather if this one is 0, and you're making an AND operation where everything else is also 0, the result of that is just 0, right? So we're kind of focusing on this comparison right here. You know, comparing this bit to this bit, what happens? So what we can do is that we do event.current.modifiers, and then we do AND because we want to do an AND operation on this, and then event modifiers, I guess. I forget the name of this type. Event modifiers.alt. So this is going to return an integer, right? Or it could be an event modifier enum, so I'm not sure if it does. So if we do this operation, the result of this one is either going to be exactly equal to Alt, that is a bunch of zeros and a 1 here, which means that it's being held, or it's going to be equal to 0. So just to make a quick comparison, I would just do not equal 0. So that means that we are holding Alt. That was a very lengthy explanation of this. Did that make sense, or did it become more confusing than useful? I don't know. Chat is dead silent. The students, that is. Everybody's just like, geez, we know this. You've had a lecture on it, but people were like divided about like whether or not it was just bit shifting or it was just talking about flags in general. Anyway, okay, whatever, let's move on. Okay, so now we have a way of checking, you know, are we holding Alt or not, right? So we only want to change radius if the event type is the scroll wheel and we're not holding Alt, right? So holding Alt is false, right? So now if I hold Alt, I can now zoom in and out, right? Using the scroll wheel again. So now everything's all good and neat again. So I can still use my camera, and then if I stop, I can use the scroll wheel to change the radius again. Yeah. All right. We are running very short on time. Because I also wanted you to have some time to add some features to this. All right, so there was one more thing that was bothering me, and that is that if you look at how quickly this one is zooming right now, you see that when it's very small, it makes like very large increments in proportion to the whole circle, right? But if I zoom out, then it makes kind of small adjustments. So you kind of want this one to be able to adapt to whatever scale you're already at, right? So there's a very neat way of doing that. So right now we set the radius to, we change the radius with scroll direction times 1, right? But instead of doing that, we can change the radius by multiplying it instead, right? So if we multiply it by 1, or rather the scroll direction plus, let's see, do we have, oh yeah, this is sine of, actually no, we want 1. There we go. 1 plus the scroll direction times a percentage. So in this case, like, we can then like change it to be a percentual increase rather than being just adding to it, right? Because what's going to happen is that we're going to multiply by 1 plus something, which can in some cases be 1 minus, right? So if we change this to 0.1, that means that we're going to change 10%. It's either going to be reduced by 10% or increased by 10%. 10% sounds like it might be a lot. I'm not entirely sure. Let's do 5%. There we go. So now as we approach a smaller circle, you can see that it doesn't like jump massive steps. And if we zoom out, then we can still kind of like do relatively precise radii changes, right? But it's not like horribly slow, like it is when it's very small, right? Yeah, so I think that's a neat little way to make sure that like you don't have like weird value ranges that are frustrating to work with. It's kind of nice to make sure that they scale to different scales. I think it's time for assignments. Are you ready for assignments? Do you want assignments or do you not want assignments? Oh, by the way, the assignments that I'm giving you, they're not graded. So like, I'm just giving you things that you can do if you want to. And then the course assignment you have was not made up by me. That was done by some nebulous entity in future games. So I don't know what that is. I'm not responsible for that, you know? And again, optional assignment. If you don't have time, don't do it. So make sure you take care of yourself. So it's mostly like, again, I don't care if you do assignments or not. I just want you to learn the things you want to learn and be, a resource available for you, right? Okay, so let's talk about the assignment that I want to assign. The first one. Number 1 is that you should add some sort of way of actually spawning prefabs. We actually haven't talked about how to spawn prefabs, but I think that would be a good thing for you to Google as well, to try to figure out, how would you spawn prefabs in edit mode, right? And also including making sure that it's undoable and everything, which is an extra step. So number 1 would be to add button to instantiate would be the term, yeah. Because now spawn has a different meaning. I just like saying spawn instead. Hacking new ECS ruining the word spawn. Or wait, was it the networking system that used spawn? I don't remember. Right, so this would be the first one. add a button to instantiate the prefabs. And again, it should be undoable and everything. So that's an important part of that. 2. Actually, so the second one is to crash Photoshop. So I'm just gonna save that file and reopen that. I don't know how I do this. I'm so confused. And it seems to only happen when I use my tablet, but I'm not pressing any tablet buttons, I'm pretty sure. Anyway, random rotation. So in addition to just like placing the props at some location, also give them a random rotation, so that each tree or whatever prefab you place we just have the random orientation. And it's good that I'm drawing something that's like angularly symmetric, so there's no way to tell what direction they're looking, but you get the idea. That's too big. There we go. Spin the other direction for the other one. That's wild. Third one is pretty advanced. You don't have to do it if you don't want to. So this third one is to draw the prefabs before you actually place them and instantiate them in the scene. All right, cool. Does that sound good? Sorry for my handwriting. It's not great. Especially when I like write instantiate very quickly because I'm like, Jesus Christ, what a long word. Oh, the circle thing. We didn't do the circle thing. I didn't even add it to the assignment. Oh no, it's too late. We can still do the circle thing. I can do that. Now I kind of want to add a bunch of things to this code that's going to make it a little bit more confusing. Where do we draw the circle? It's down here. Okay. Right. The thing I want to add now is that we have this concept of raycasting given a 2D position, right? I feel like there should be a function to get a ray given that 2D position, right? So let's do that. Let's call it get tangent ray. So essentially, we would do this whole thing for a 2D point, or tangent space position. There we go. And then we return that. There we go. So now we should be able to replace this whole thing with get tangent ray for P. All right, I'm just gonna make sure that works. So maybe I broke something, who knows? I also feel like the scroll direction is inverted, I think. Well, it seems to still work, so that's good. All right, so now we have the get tangent ray function. That's gonna make things way more easier to do. So now we need points around the perimeter of the circle, right? We would get a t value, so that would be I divided by circle detail. This has to be a float. And we also need to, we don't need to, but given that I'm going to use the handles draw anti-alias polyline function, and that one is only going to draw, you know, from the start point to the end point, but it's not going to draw, it's not going to connect to the end point to the start point, right? So in order to do that, we need to like, either we can add some special functionality to like add the first point again to the list, but I'm just going to calculate it once more. So that's why I'm adding +1 here. So we do like one extra like point. So I'm going to do +1 there too then. Yeah. Angle and radians, so that would be t times, where's tau? Where did I put tau? Not in here. Jesus Christ. Not okay. Yeah. Cosine and sine, and now we have 2D vector, and the radius is automatically added by the get tangent ray function, because we're multiplying that one over there, right? Yeah. So I think that's kind of actually it. Now we just need to add it to the circle points. Actually, I should probably do circle detail -1 and not have those there, because that's kind of confusing. And then we assign the direction. Oh yeah, wait, these are just the points along the circle, but we haven't raycast it. Okay, that's fine. Oh, actually, we're getting this is a difficult question. What happens if you fail a raycast? That's, oh no. We could actually make this into a ray array. Neat. Okay, so now we have a function that basically gets all the rays around the perimeter of the whole thing, right? So the idea is that we're going to raycast down, and then whatever it hits, like all of those points, we're going to make a draw a line along all of those points, right? Actually, we can go one step further. Let's just make this into points immediately. Change this one more time. Because we can recast this for a loop as well. All right, and then we're going to set it to the hit position. And if the raycast misses, I guess I'm just going to set it to, I don't know, the origin of the ray or something. Because it has to be something. I was going to set it to the previous point, but the previous point could actually fail. If it's like the first one fails, then there is no previous point, right? Alright, so now we have all the points, and then we just need to draw them. So, handles dot draw a polyline and point. This should not be called point. Neat, I think that's it. So that's going to be instead of this wire disk. And there we go. Look at that bloop. Might need some margin because it's intersecting the thing there. How many centimeters? 2 centimeters. There we go. That's a little bit better, not perfect. You know what, we're gonna have 128 of these. There we go. More detail. There you go. Is that good? Are you happy, Twitch chat, who asked for this? Alright, okay, that's gonna be it for the stream then. Thank you all so much for joining. And for those of you hanging out on Twitch, or even the students, if you want, feel free to hop into our Discord. We have a Discord server full of like game developers and people who play games, and a lot of people in the queer community. So feel free to hop in. Yeah, or if you want to share your stuff, if you have questions about doing things in Unity or whatever. Yeah, I'm gonna upload this to YouTube later on. I don't know how long that's going to take because video editing takes a heck of a long time. But yeah, I have a bunch of other tutorials on YouTube as well in case you want to check that out. There's also part 1 is already on YouTube of this whole tutorial series thingy. Yeah, so feel free to look at that in case you missed the first one. All right. Was there anything else I was going to plug? Ashley. I'm going to plug Ashley. Ashley's real cool. Go check out her stuff on Twitter, at Kyperia on Twitter. She does like really cool fractal shenanigans. If you're into like fractal ray tracing stuff, if you're interested in Rust, there's also a bunch of Rust stuff. So yeah. All right, that's it for the stream. Thank you all so much for joining. Have a good day, night, evening, wherever you happen to be. It works. Okay, I'm sorry. I totally missed that. Oh, jeez. It's a bad teacher. I'm gonna get bad reviews. The head teacher is gonna ask you and be like, hey, how was Freya as a teacher? And you're gonna be like, well, it was pretty okay up until that point where she had like 2 apply modified properties clients, and it was so cringe. And it went on for forever.